There is a kind of darkness in the universe that does not behave like darkness at all. A darkness that does not swallow light, does not bend it, does not dim it, but simply erases its existence. The first time telescopes drifted over that region, they expected to meet the familiar quiet of deep space. Empty, yes. Lightless, yes. But predictable in the way the cosmos usually is. Silence is rarely mysterious. Yet the readings that returned were not silence. They were refusal. A refusal so gentle, it almost felt deliberate. Photons, traveling toward that place, would move steadily, rhythmically, as if nothing unusual waited ahead. Then, just before crossing an invisible threshold, they would lose coherence, lose identity, lose the very thing that makes them light. Not absorbed, not scattered, not transformed, just undone. Scientists hesitated to name it that way at first. Undone is a word that belongs to dreams, not physics, but the data left no comfortable alternative. Something in that region, the one now whispered about as the Starless Zone, seemed to unmake illumination itself. If you're kind enough to help this quiet space continue breathing, a soft like, a gentle share, or simply letting the channel rest in your subscription keeps the light on for stories like this one. Imagine drifting toward the boundary now, past the clusters, past the cold scatter of ancient stars, into a stretch of universe where distance grows thin and silence begins to shine in its own strange way. Even from far away, instruments noticed something unnatural. Not a void, not a shadow, but a form of absence with structure. The gravitational field around it quivered in a pattern too stable to be random. The cosmic microwave background, aglow from the very dawn of time, dipped subtly near the edge, like a sheet sagging under the weight of an invisible hand. Radio waves approaching the region returned incomplete. Gamma bursts vanished entirely. Only one thing never changed. Whatever the Starless Zone was made of did not want light. There was a moment in one of the earliest recordings when a stream of photons approached the boundary. Frame by frame, they held their form. In the next, they didn't. The researcher who first analyzed that sequence described it as watching brightness exhale and choose not to inhale again. Another said it felt like the universe remembering how it looked before illumination was invented. Because if the cosmos had a childhood, it was dark. Not the darkness of empty rooms or unlit streets, the darkness of pure potential, a state where light had not yet negotiated its place in reality. The Starless Zone feels like a pocket of that first memory, a place that kept something primordial, untouched, untransformed. When the data teams superimposed gravitational maps over the region, they found a boundary far too defined for coincidence. A curve, a shell, a sphere sculpted by something other than matter or energy as we understand them. Inside it, there was no measurable temperature, but also no true cold, no motion, but also no stillness. A strange equilibrium, as if the laws that normally govern existence were paused, waiting for instruction. Some researchers, hesitant, careful, sleepless, began proposing the unthinkable, that this region might represent the universe in a state that predates photons, a portion of space that never fully joined the transition into a lit cosmos, a remnant of the pre-visible era, a survivor from a version of physics that ended before stars were even possible. Others resisted the idea. How could a piece of the early universe remain untouched while everything else evolved? What mechanism could preserve an ancient physical rule inside a modern cosmos? And why would light, the medium through which the universe expresses itself, have no jurisdiction there? But resistance does not erase evidence. The contours held. The pulses continued those faint, nearly unmeasurable oscillations that repeated at intervals too precise to be random. A breath of darkness. A rhythm without brightness. A presence that didn't emit, reflect, or absorb anything, yet undeniably existed. The first time I listened to the recordings of those oscillations, they didn't feel like a signal. They felt like architecture, the skeletal frame of something the universe built long before we ever named stars. And when gravitational wave detectors swept past the region, they caught a whisper, not a sound, but an indentation, a soft curvature in space-time itself, as if the starless zone were humming, as if silence were holding shape. No one fully agreed on what it meant. Some said it was a relic of the inflation era. Others claimed it was a rupture, where our universe meets a domain governed by different laws. A few, usually in late night, conversations that never made it into published papers, wondered if the starless zone was a memory the universe refused to forget. Because every theory led back to a single unsettling idea. Light might not be fundamental. It might be optional. A phase, a convenience, a layer painted over something more original. And if that is true, then somewhere out there beyond the constellations, beyond the stellar winds, beyond the galaxies still spinning like slow lanterns in a sea of time, there must be places where creation still rests in its unlit state. Places like this, as you let that thought drift through you, let yourself feel the edges of the darkness again. Not threatening, not empty, simply vast, in a way that makes light seem young. A region where illumination dissolves into its own silence, where visibility loses its meaning, where the universe shows a part of itself that predates the act of shining. The instruments that map this frontier noticed something else, something delicate, easy to miss unless you listen with the softest part of your attention. A faint, repeating pressure in the data, like a pulse, too slow to be a signal and too consistent to be noise. A pulse, the color of nothing. A pulse shaped like a pause. A pulse that feels strangely alive. It was the first sign that the starless zone is not an emptiness. It is an interior, and deeper inside it, something is waiting to be understood. The moment telescopes first realized something impossible was happening, the data stream looked almost peaceful. A line of photons approached a region of space, as they had done countless times before, steady, obedient to the geometry of the cosmos, carrying the soft persistence that light has perfected over 14 billion years. And then, they weren't there. The disappearance did not resemble a collapse. It did not ring like an error. It came through the instruments as a quiet, perfect absence. A clean break in a sequence that should never break. A vanishing that left no echo of what had been. Observatories are used to lost dust, clouds obscure, sensors fail, cosmic rays distort, distant galaxies slip behind the drifting fog of interstellar medium. But this was different. This was a subtraction so precise it felt intentional, as if the universe had edited the frame. The first team that reviewed the data blamed the software. The second blamed solar interference. The third dismissed it entirely. Yet all three teams had no choice but to return to the same strange truth. Light approaching that region did not dim. It ceased. To understand why this alarmed them, you need to imagine the language photons speak. They rarely vanish without leaving a trace. Even absorbed photons register as heat, momentum, or ionization. Even scattered photons leave signatures of their direction. Even annihilated photons leave measurable energy trails. But in the starless zone, the language of light seemed to reach a point where the alphabet itself dissolved. As more telescopes were directed toward the coordinates, datasets began to overlap. Every instrument, infrared, optical, ultraviolet, radio, reported the same phenomenon. Before crossing a certain invisible boundary, electromagnetic waves behaved like they always had. But within the boundary, nothing. Not the nothing of empty space, which still has geometry, vacuum energy, and quantum fields simmering beneath its silence. This was another category entirely. A deeper quiet. A quiet that did not simply decline to speak, but declined to exist. Scientists began to mark the edge of the region as a transition interface, though many privately admitted the term was a placeholder for ignorance. The interface wasn't a surface. It wasn't a gradient. There was no change in density, no anomaly in temperature, no gravitational wall. Everything outside was normal. Everything inside was beyond interpretation. The absence behaved like a form of matterless opacity, a veil without particles, a boundary without substance. A senior researcher described it in a late-night report as a silence with rules. Another called it an unlit membrane. None of the terms survived peer review, but the fear hiding inside them did. When light disappears without trace, scientists do not ask why first. They ask, how far does it go? So they probed, cautiously, obsessively, like wanderers testing the depth of a chasm with pebbles they could no longer hear hitting the ground. Every probe told the same story, a radius so vast it outscaled clusters, a boundary so smooth it defied cosmic history, an interior so mute it rejected every known form of illumination. What made the disappearance more unnerving was its consistency, as though the boundary was not reacting to light but enforcing a rule that predated it. There were no fluctuations, no patches, no holes, no thinner places where light could slip through. The region was exact down to a scale that contradicted the disorderly nature of cosmic evolution. A place that strict should not exist 13 billion years after the birth of everything. Entropy should have chewed through its symmetry long ago. Gravity should have twisted it. Dark matter should have smeared it. Galaxies passing nearby should have distorted it. But the Starless Zone resisted all influence, like a relic floating untouched through eras it had no intention of participating in. There is a moment in every major discovery when the data begins to whisper in a direction no one wants to recognize. This whisper came from gravitational sensors whose readings did not match any model. Within the vicinity of the boundary, space-time curvature trembled, not violently, not chaotically, but rhythmically. A faint oscillation, repeating at intervals too stable to belong to random cosmic noise. A heartbeat so large its pulse traveled light years, and so subtle only the most sensitive detectors could feel it. Scientists called it a metric ripple, but secretly they wondered if such a ripple could be produced by a structure not meant to be seen, but meant to persist. The ripple hinted at architecture, geometry, hidden inside darkness, a scaffolding without matter or with matter so deeply transformed that no known interaction could reveal it. Some theories suggested an exotic phase of vacuum, a region where the Higgs field behaved differently, where particles lost the ability to maintain mass or charge, where electromagnetism had no authority. Others ventured into far stranger territory. Perhaps the Starless Zone was an uncollapsed region of primordial space-time, a pocket of the universe that never completed its transition into the physical laws we consider normal, a fragment of pre-light physics, a fossil from an era before photons. Imagine the early universe, a time when temperatures were so high that matter could not settle, and energy pulsed through dimensions, still negotiating their purpose. A time before stars, before visibility, before the cosmic microwave background cooled enough to carry color. If a region of that ancient state somehow avoided evolving with the rest of the cosmos, it might appear exactly as the Starless Zone appears now, immune to light, indifferent to illumination, still bound to the rules of a version of reality we no longer inhabit, a fragment of before, not a void but a memory. Some physicists refuse to accept this hypothesis. If such a region existed, they argued, it should have collapsed under its own exotic conditions. But collapse implies participation in the universe's ongoing negotiation. This region does not negotiate. It isolates. There is a dangerous beauty in that isolation. A stillness no star could survive. A silence that does not welcome or reject, it simply is. As data accumulated, the boundary began to look less like a frontier and more like a diaphragm, a thin layer separating two incompatible states of being. Light on one side, the absence of light's meaning on the other. not because the region consumes it. Consumption leaves energy signatures. This left none. Instead, photons approaching the boundary seemed to lose definition, as if the region erased the possibility of being seen, as if visibility itself was unwoven at the threshold. One researcher described the moment of disappearance not as annihilation, but as a transition from existence to irrelevance. To her, the photons did not stop. They entered a domain where their properties no longer mattered, a domain where illumination has no vocabulary. If you let yourself imagine drifting toward that threshold, the image becomes strangely gentle. The boundary would not glow. It would not shimmer. It would not resist your approach. It would be perfectly silent, perfectly smooth, perfectly indifferent. And as you moved even closer, the stars behind you would grow ever so slightly dimmer, not because of distance, but because the subtle curvature of space-time around the boundary bends their final threads of light away from you. Not violently, not even noticeably, unless you were watching with the softest tools of attention. Like a curtain of gravity encouraging luminosity to turn around. Even before reaching the boundary, the universe begins to feel as if it is inhaling, drawing quiet inward, preparing to show you something it rarely shows anyone. As you float in that inhalation, the details of the cosmos fade not in intensity, but in urgency. The universe feels slower, older, less concerned with being understood. The Starless Zone is not a place that invites answers. It invites surrender. A surrender not of safety, but of assumptions. There is a moment the researchers describe often, though never in published papers. A moment when they felt as though the darkness was not behaving randomly, but expressing a preference for silence, a preference predating the invention of light. The closer their instruments moved toward mapping the interior, the more a pattern emerged in the oscillations. Not a signal, not a message, but a shape. The shape repeated, subtle, soft, almost like the curvature of a wave frozen in mid-motion. A curve that whispered of symmetry before symmetry fractured into the universe we know. Some believed they were watching quantum geometry in its most primitive form, space-time, still in its original rhythm, unscarred by stars. Others believed they were watching a doorway, not a portal to another place, but a portal to another time, one that still exists because the laws inside that region refuse to age. Still others, quietest of all, felt the region was a boundary between universes layered too closely to separate, and the Starless Zone was the seam. None of these theories were proven, but none were disproven either. Because the Starless Zone does not reveal its interior, the boundary does not permit vision. Light cannot cross. Information leaks only through gravity, and gravity tells stories slowly. Yet even gravity could not hide one truth. The region is not expanding or contracting, it is steady. And steadiness, in a universe ruled by entropy, is suspicious. It suggests something maintained, something preserved, something allowed to remain as it was in a cosmos where nothing stays as it was. As you drift in thought around that boundary, the familiar idea of darkness begins to change shape. It stops being the opposite of light. It becomes a state with its own history, its own personality, its own pulse. A pulse that does not echo through space as sound, but through curvature as presence. A presence that feels ancient. And the more you imagine the strange calm inside that region, the more you sense something contradictory. The Starless Zone is not empty. It is full of a physics we do not yet understand, full of a silence that is not silence, full of a memory the universe still carries lightly in the folds of its fabric. You begin to wonder not what lies inside, but why this region remains untouched, why nothing has disturbed it, why nothing has evolved it, why nothing has claimed it, why the universe allows it to persist. And in that wondering, something quiet gathers at the edge of awareness, the realization that perhaps illumination is not the default condition of existence. Perhaps brightness is the exception. Perhaps the universe spends most of its life in forms we cannot see. And the Starless Zone is a reminder of that majority. a reminder that light is temporary, a reminder that visibility is fragile, a reminder that the cosmos once lived without shining, and perhaps, somewhere deep inside, some part of it still chooses to. The data continues to pour in. The patterns grow more intricate, the gravitational murmurs more rhythmic, the boundary more perplexing, more elegant, more precise. Every discovery tightens the question rather than answering it, and somewhere within that tightening, you feel the universe leaning closer, as though preparing to show you what happens when illumination tries to enter a place older than itself. As the data continued to accumulate, the boundary began to reveal itself not through light, but through everything light could not touch. Gravitational sensors traced a contour that no visible instrument could map. Radio telescopes caught a faint bending in the background noise, a subtle detour in the path of distant waves. Even neutrino detectors, usually indifferent to almost everything, returned readings that suggested they, too, felt a difference when passing near the region. The universe was drawing a line, not with matter, not with energy, but with absence, a line so precise it felt carved. The shape that emerged was neither sphere nor shell in the traditional sense. It lacked the imperfections that gravity, time, and collisions with drifting matter inevitably create. This was smoother, more deliberate, the sort of smoothness that suggests something untouched by chaos. Scientists began to describe it, in private notes and late-night voice logs, as a geometry without texture. That phrase stayed with me. Geometry without texture. A boundary so pure that even time seemed to glide across its surface without resistance. What confused researchers most was not the smoothness, but the silence. The boundary did not emit, did not reflect, did not distort. It simply bent the rules around it in a way that made every instrument stutter. If light were a language, the boundary was a place where all dialects vanished at once. Imagine drifting toward it with no camera, no sensors, nothing but the soft intuition you carry when the world around you turns strange. You would not see the boundary. You would not hear it. You would not feel it as pressure. Instead, you would sense a thinning, a gentle shift, almost like approaching the moment just before sleep, where your thoughts stop insisting on form. The Starless Zone begins with that thinning, and then, somewhere in that thinning, comes the realization that the universe is bending, not collapsing, bending space subtly, bending time slightly, bending the very definition of distance. This bending is what first suggested structure, because even in places where light cannot speak, gravity continues to hum its quiet, patient song. And the gravitational hum around the boundary was not random. It was patterned. Faint waves, long, slow, mathematically, elegant, rippled outward, as if the boundary were breathing, not inhaling or exhaling, but maintaining rhythm the way a heart maintains tempo long after the body has learned the habit of living. The equations describing this rhythm carried a strange beauty, a symmetry that hinted at deeper order, a structure that felt older than galaxies, older than color, older than the idea of brightness. Some scientists refused to publish what the equation suggested because it sounded too poetic, too metaphysical, too eager to humanize the cosmos. But the suggestion lingered anyway. The boundary behaves as though it remembers something. Not memory in the biological sense, but memory as a physical state, a trace left behind from an era when the universe had not yet decided it should shine. The more the boundary was studied, the more that idea gained weight. Consider this. In the earliest fractions of a second after the universe came into being, light did not yet exist as a free traveler. The cosmos was too dense, too hot, too entangled. Photons were trapped in a fog of charged particles, unable to roam. Only when the universe cooled and expanded did light slip free, beginning its long journey through all the epochs that followed. But what if some regions never entered that transition? What if they remained locked in the pre-light phase, untouched by the shift that allowed visibility to exist. The boundary of the starless zone seemed to be defined by that very division, a border between universes of different age, different memory, different physics. Even those who rejected such interpretations were forced to confront the consistency of the data. Every form of electromagnetic radiation died upon contact. Every wavelength, every frequency, every photon. Yet gravity passed through effortlessly. So did neutrinos. So did the mathematical form of space-time itself. It was as if the boundary enforced a selective silence, a silence targeted at illumination alone. To imagine such a boundary, think of a coastline not made of sand or stone, but made of permission, a place where certain laws are allowed to exist and others are denied. A frontier not of matter, but of potential. The shape of this frontier was even stranger. Gravitational mapping revealed that the boundary was not perfectly spherical, but subtly elongated, a form that hinted at internal tension, something stretching very slightly, as though the region inside were resisting collapse or maintaining a shape against the pressures of an expanding universe. The elongation was too small to see with the eye, too precise to be an accident, too repeated to be noise. It was, unmistakably, structural. But what structure, what framework could maintain its form while allowing no light to exist within? The theories spiraled quickly. Some argued for topological defects, wrinkles in space-time left over from the early universe. Others spoke of false vacuum pockets, regions where physics had stabilized into a different minimum. A few, speaking quietly as though afraid of their own imagination, suggested that the boundary was not enclosing something but shielding everything outside from what lay inside, not protection, separation, because the absence was not empty. It was full of something that negated illumination. If you were drifting near the boundary in some hypothetical craft, your instruments would not warn you. Your eyes would not detect danger. There would be no glow, no shadow, no turbulence. Instead, you might feel the way astronauts describe approaching the Terminator line on a moon, a sudden shift in perception, a sensation that does not come from the body at all, but from the brain's inability to categorize what it is sensing, a stillness that feels alive. That living stillness is perhaps the most disquieting part of the starless zone. It is not violent, not chaotic, not threatening. It simply is itself with a confidence that feels older than the purpose of stars. The boundary holds that confidence, a quiet certainty in its form, a refusal to be altered. Researchers realize something even more unsettling. As you map the gravitational curvature more precisely, a pattern emerges inside the pattern, a layering. The boundary is not a single surface. It is a series of subtle gradients, not gradients of energy or matter, but gradients of rule. Each layer behaves like a narrowing of possibility, a constriction of physical freedoms. The closer you get to the interior, the fewer interactions remain allowed. Light fails first, then electromagnetic force. Then, perhaps deeper still, even the familiar mathematics of space-time begins to soften. The boundary is not a wall. It is a transition in the language of existence. One physicist wrote in a private note, never published, "It is like approaching a poem, written in a language we once knew, but have now forgotten." Another wrote, "The boundary is not the edge of a place. It is the beginning of an older universe." But among all these interpretations, one question grew louder and impossible to ignore. If the boundary is so perfect, so stable, so immune to the chaos of cosmic evolution, what keeps it intact? What maintains the symmetry? What preserves the geometry? What memory or mechanism allows it to resist billions of years of gravitational tides? The answer hiding inside the question was even more haunting. Perhaps the boundary does not need to resist. Perhaps everything inside the region is so fundamentally different that the forces shaping the rest of the universe simply do not apply. And if that is true, then the boundary is not being preserved. We are simply witnessing something that never needed to change, a relic of original physics, a preserved pocket of pre-light existence. As these possibilities unfolded, the tone of scientific inquiry shifted, less like exploration, more like archaeology, as though researchers were brushing dust away from the earliest bones of reality. The boundary became not just a frontier, but a clue to what the universe was before the universe was visible. When computational models attempted to simulate the internal structure of the region, they failed in surprising ways. Equations diverged, constants lost meaning, parameters collapsed toward zero or surged toward infinity. The models behaved as if they were being asked to describe a system that operated on rules older than the mathematics used to define them. Some simulations produced shapes, wisps, ridges, slow-folding arcs, not of matter, but of pure geometry. Curvatures without particles, surfaces without energy, forms made only of possibility. It was in these simulations that a faint pattern began to appear. A repeating crest, a rhythm of curvature similar to what gravitational sensors detected around the boundary. This crest became the first real visualization researchers had of the invisible frontier, a soft, wave-like shape, curving inward, then outward, like the breath of something vast. Somebody on the research team said quietly, "It feels like looking at the ribs of the universe." No one corrected him, because in a way, it was true. As you picture that shape soft, elegant, repeating the boundary becomes easier to imagine, not as a place where darkness rules, but as a place where the universe has chosen silence over illumination, a place where laws have not yet agreed to let light exist. And as that silence deepens around you, you feel yourself drifting closer to the realization that the boundary is not hiding something. It is revealing something, not by shining, but by refusing to shine. And somewhere within that refusal, just before the mind begins to ask what lies inside, you feel the gravitational rhythm again, a pulse so faint it might not exist at all, yet so steady it feels like the first memory reality ever formed. The closer scientists looked at the boundary, the more one particular event stood out, a recording almost lost among thousands of datasets, yet unmistakable once found, a sequence where, for the first time, instruments captured not only the disappearance of light, but the moment it began to fail. It was an accident. A deep-field telescope scanning background galaxies drifted slightly off target, sending a stream of photons through the edge of the starless zone. The exposure lasted less than a fraction of a second, yet that fraction rewrote everything. At first, the captured frames looked normal, a distant star cluster glittering through the cosmic medium, its photons traveling steadily along predictable trajectories. But as the photons neared the invisible frontier, something subtle stirred. Not a bend, not a blur, not a shift in color or angle, a hesitation, a measurable slowing in the internal coherence of the light, the rhythm that keeps each photon's identity intact, an unthreading so faint it would have been overlooked if not for a grad student who, out of simple curiosity, replayed the captured data at 1,000 times magnification. There, in the stretched-out frames, she noticed it, the improbable, impossible flicker. Not flicker as in dimming, not flicker as in distortion, but flicker as in confusion, as if the photons themselves were unsure whether they should continue being photons. This hesitation began precisely 3/trillionths of a second before disappearance, a boundary written not in space, but in time. The more she watched it, the more disturbing it seemed. In the frame before vanishing, the photon's waveform didn't collapse, it unraveled. Unraveling, in quantum language, is not death, it is memory loss. The photon forgot how to be a photon. It forgot its frequency, forgot its phase, forgot its definition as a particle of light. And once it forgot, there was nothing left for our instruments to detect. This was the first moment when the starless zone stopped being a mystery of darkness and became a mystery of physics itself. A physics that felt ancient, unfamiliar, patient. Researchers tried recreating the conditions in simulation. They failed again and again. Every model assumed some mechanism: absorption, scattering, annihilation, yet none matched the clean disappearance. Eventually, a physicist proposed an analogy that made everyone uneasy. What if the region is enforcing a prior rule? A rule older than electromagnetism? A rule from a time before the universe allowed light to exist freely? The idea was simple, yet devastating. Light requires permission, and the starless zone refuses it. To understand how radical that is, consider every place you have ever seen, every star, every reflection, every atom, every nebula. All of them are visible because the universe made a choice billions of years ago to let photons roam. But the starless zone seems to occupy a reality where that choice never occurred. And the boundary is the seam between these realities. As researchers studied the captured event more closely, another oddity emerged. It wasn't just the photons passing through the region that unraveled. Even photons approaching but not yet touching the boundary showed subtle anomalies. A slight phase drift, a gentle tug in waveform alignment. Not enough to erase them, but enough to suggest the boundary exerted influence from a distance. Imagine standing near the ocean, feeling the pull of the tide not on your feet, but on your breath. That's what the data felt like, a gravitational murmur shaping the behavior of light before contact. These murmurings created a region around the crust. Boundary scientists began calling the pre-null halo, a faint zone where the rules of visibility start to soften, as if reality is preparing light for its unmaking. Inside the pre-null halo, the universe feels thinner, not weaker, not emptier, but thinner in the way dawn feels thin, not because darkness is losing, but because something new is about to unfold. What unnerved the teams analyzing the data was how precise the halo boundary was. No natural process in cosmology draws such clean lines. Galaxies smear, nebulae fray, void edges scatter into filaments. But this was a line crisp enough to slice concepts. It suggested classification, as though the cosmos was sorting its own physics. And in that sorting, light was the first to be set aside. The reaction of the scientific community was predictable. Panic hiding inside precision. Lab meetings filled with cautious phrases: local anomaly, measurement inconsistency, instrumental interference. But none of those phrases explained the growing pattern of evidence. Light was not failing randomly. It was failing with perfect consistency. Failing in a way that suggested a law, not an accident. One research group attempted to measure the thickness of the pre-null halo by firing controlled photon bursts at varying angles and velocities. Their results were terrifying. The halo adjusted. It adapted to the incoming light, matched the angle, matched the energy, matched the frequency. It behaved not like matter or field, but like a rule that tracks every photon approaching the starless zone and prepares to erase it in precisely the correct configuration. This was the first time someone spoke the words out loud. This region edits reality. The room fell silent after the sentence, not because it was absurd, but because no one could argue with the data. Every photon entering this space was not destroyed, it was rewritten into nothing, as though the rule inside the starless zone cannot express brightness, just as a language might lack a word. And the universe on our side of the boundary can't translate what happens inside. Some theorists proposed that the boundary is actually a collision between two distinct phases of space-time. On one side, the electroweak symmetry broke in a way that allowed light. On the other side, it never did. Two realities touching, two childhoods of the universe meeting at a seam. Others proposed that beyond the boundary lies a region where the dimensional structure of space-time is different, not our familiar four, but something subtly shifted, a dimensional tilt that makes electromagnetic behavior undefined. But no model fit as elegantly as the most unsettling one. Light has no history inside that region. It has never existed there. Not once. Not at the beginning of time. Not now. Not ever. The interior is a place that predates illumination, conceptually a pocket of the cosmos, frozen in a primordial regime, untouched by the transformation that allowed visibility to arise. And the moment photons approach that interior, they simply lose meaning. The flicker, captured by the Deep Field Telescope, that brief heartbeat of confusion before disappearance, was the photon attempting to obey a rule it had never encountered, a rule that tells it, "You are not permitted here." But the rule does not repel, it erases, not violently, not destructively, softly, quietly, perfectly. Erasure without force. Erasure by irrelevance. Some data analysts compared the phenomenon to quantum decoherence, inverted not the process by which a particle becomes definite, but the process by which definiteness becomes impossible. The boundary is the birthplace of impossibility, a horizon not of energy, but of meaning, and deeper, inside the region, far beyond where any photon could survive. The gravitational mapping began to reveal another mystery, a structure, not matter, not radiation, not interaction, but a pattern of curvature so subtle it could only be detected by stitching together hundreds of observations taken months apart. A repeating shape, soft, continuous, rhythmic. The same rhythm scientists had been detecting around the boundary, but now seen inward, expanding and contracting like the ghost of a breath. The structure seems to occupy the interior the way bones occupy a body, quietly, invisibly, providing form without announcing itself. One scientist described the shape as architecture made of absence. Another said it looked like a cathedral built from rules instead of matter. A third whispered that it resembled the universe before it learned how to shine. And so the question grew, slowly, quietly, like a tide rising in the background of every conversation. If light cannot cross the boundary, what can? What moves inside a place where illumination unravels? Gravitational signatures say something is there. Not matter as we know it, not dark matter, not energy, something older, something the universe did not erase when it transitioned into visibility, something that has waited in the unlit silence since the beginning. And as you stand at the edge of this thought, this realization that the boundary is less a wall and more a memory, the gravitational pulse inside the region grows clearer, slow, measured, endlessly patient, almost like the steady breath of something that was alive long before the concept of life existed at all. The deeper scientists probed into the starless zone, the clearer one uncomfortable truth became. More than darkness lived inside it. Darkness, at least as we know it, is passive. It is the result of a world without photons, not a world that rejects them. But the absence within the starless zone was not passive. It had profile, shape, behavior. Even though no known particle survived the boundary, gravity, the most patient messenger the universe has ever known, did. And gravity carried back whispers, tiny distortions, soft oscillations, patterns so faint they could only be revealed by weaving together thousands of hours of readings, each one measured against the quiet background hum of space-time. What emerged from this tapestry of signals was unsettling. There were structures inside, invisible, intangible, untouchable by light, but undeniably present. They did not move the way stars move, or drift the way dust drifts, or pulse the way magnetars pulse. They moved with a different storyline, a storyline of rules older than the ones we know. Researchers began calling these interior forms gravitational contours, though even that name felt inadequate. A contour is something traced across a surface, but these shapes produced no surface. They traced themselves across nothing. One theorist described them as creases in the idea of space. Another wrote in her notes, "This is geometry thinking about itself." But whatever name they tried, nothing softened the strange truth that the interior held an order, a gentle, meticulous order, a harmonized, quiet. Inside the starless zone, the universe seemed to be remembering how it once behaved before illumination existed, and the gravitational contours were the closest thing we had to its memories. The first mapping attempts revealed three significant features. The first, a central thinning, a region of reduced curvature, as if the core of the starless zone were calmer than its shell. Not a void, not emptiness, but calm, a physical silence so deep that space-time itself seemed to relax. The second, a ring-like structure circling the core, shaped not by matter or force, but by a symmetry, something mathematical, something untouched by the chaos of galaxies forming and collapsing over billions of years. Mathematicians were bewildered. The symmetry was too precise to be coincidence, too ancient to be engineered, too stable to be natural. And the third, a pulsing boundary, identical to the heartbeat-like rhythm detected outside, slow, consistent, unchanging. These layers, core, ring, boundary, hinted at a cosmic anatomy. But an anatomy of what? It was here that the most daring hypothesis emerged. Not publicly, not at conferences, only in private conversations held in dim hallways, over unfinished cups of coffee, in the early morning stillness when the mind is vulnerable enough to admit what it has been trying not to see. The hypothesis was this: the starless zone might be a relic of the universe's first state, a leftover piece of primordial existence, older than stars, older than atoms, older even than the laws that make light possible. In that first state, the universe had no transparency, no visibility, no radiance. Everything was locked in a dense, trembling fog of potential. Imagine a child before learning to speak, whose whole world is pure sensation and silence. That was the universe in its beginning, a cosmos without language. And the starless zone may be a chamber of that childhood, a place where the universe's earliest memory has not yet been overwritten by the age of illumination. If this interpretation is true, then the gravitational contours inside the region are not strange at all. They are fossils, the remaining bones of a universe before it learned to shine. To probe this further, scientists turn to neutrinos. Neutrinos are indifferent travelers passing through stars, planets, oceans, bodies, without noticing or caring. They ignore almost everything, but not the starless zone. When high-energy neutrino bursts passed near the boundary, they wavered. Not much, not dramatically, but enough to suggest that even particles that ignore matter could not ignore the rules inside the region. For the first time in recorded physics, neutrinos hesitated. The significance was staggering. If the starless zone influenced neutrinos, it meant the interior reality touched the deepest layers of particle existence, layers below electromagnetism, below mass, below interaction, layers at the root of what can be. One physicist said it plainly: whatever is inside that region is not playing by our universe's rules. It is playing by the proto-rules, rules that governed existence before space and time, fully committed to the patterns we recognize, rules that shaped the birth of physical law, rules that remain fossilized in this pocket, protected from the transformations that reshape the rest of the cosmos. But if these proto-rules are preserved inside the starless zone, what are they preserving? This question grew heavier as gravitational imaging improved. The ring-like symmetry appeared not just once, but in layers like concentric echoes, each one a whisper of the one before it. The patterns resembled wave interference, not of light, but of permission, a place where possibilities collide and cancel. The idea that the ring structure might be a kind of cosmic filter began to emerge. Perhaps the ring defines which interactions survive inside the region. Perhaps the ring is the reason light cannot exist there. Perhaps the ring is a leftover mechanism, a function of a universe still deciding what kinds of existence would be allowed to emerge. In the early universe, when everything was a negotiation, some possibilities flourished, others were extinguished. Light flourished everywhere except here, and that exception grew into a place outside illumination, a territory of untouched physics. As researchers traced the ring structure further, they found resonances subtle, recurring peaks in the gravitational rhythm. These resonances repeated across vast distances, suggesting a coherence beyond anything expected in a system that has survived billions of years. The resonance pattern was particularly troubling to those who understood its implications. In the language of wave systems, this kind of coherence suggests stability, not stability born of stasis, but stability born of equilibrium, a place that is exactly what it is meant to be and has remained so since the beginning. Inside the starless zone, change is not chaos. Change is impossible, and in that impossibility, there is meaning. As the gravitational contours became clearer, another discovery surfaced: a faint inward curvature in several resonance layers, almost like the shape of something folding into itself. This folding resembled the mathematical signatures of topological invariance, structures that cannot be undone without tearing the fabric of space. If these invariants exist inside the starless zone, they could explain why the region has resisted billions of years of cosmic evolution. The starless zone does not persist because it is protected. It persists because it is rooted in the geometry of the universe's foundation. Nothing can erase it because nothing can erase the earliest form of reality. Even the scientists who dismissed metaphysical interpretations could not ignore what the data implied. Inside the starless zone is a physics that predates the universe we know, a physics that may be unchanging because it is already complete. No new forces, no new interactions, no new possibilities. Only the original quiet, the gravitational contours, the ring symmetry, the central calm, they all pointed toward a place that remembers itself. A place that remembers what the universe was before illumination, before transparency, before light carved its paths through darkness. One researcher summarized it in a single line that circulated quietly among teams. The starless zone is not missing light. It is older than light. And if that is true, if the interior truly preserves the earliest state of existence, then the most profound mystery is not what lies inside, but why it remains. Why this pocket survived untouched as galaxies rose, as space stretched, as particles found their roles, as stars ignited in trillions of places. Why this one region kept its ancient silence. Why the universe never demanded it change. As these questions deepened, so did the gravitational pulses, the interior heartbeat. Not louder, not faster, just clearer, steady, patient, enduring. Like something inside the starless zone has been breathing in the same rhythm since the universe took its first breath. And somewhere between those pulses, somewhere in the spaces where gravity softens into the idea of gravity, the sense grows. The starless zone is not empty at all. Something is living there. Not life as we understand it, not biology, not awareness, but a presence. A presence made not of matter, but of the rules that made matter possible. A presence as old as existence. A presence that holds the memory of what the universe was before the dawn of illumination. And as you drift near the edge of this idea, the gravitational rhythm repeats slowly, folding you closer to the realization that whatever exists inside that unlit region has never needed light to be real. The gravitational pulses that researchers first dismissed as background noise soon became the center of every conversation. What began as faint, nearly undetectable oscillations grew clearer with each refinement in the instruments, as though the starless zone itself were waiting for humanity to learn how to listen. The pulses were not loud. They were not energetic, but they were consistent. A rhythm unfolding beneath the absence, beating through space-time with the patience of something that has never known the urgency of stars. At first, scientists assumed the pulses were an artifact, some subtle interference, some distant gravitational wave bleeding through from merging black holes millions of light years away. But those waves fade, they stretch, they distort. This pulse did not. Its intervals were constant, too constant. Its amplitude was steady, too steady. Its presence was immovable, the quiet signature of a framework that had no need to respond to anything outside it. One astrophysicist, unable to sleep after days of studying the data, described the pulse as the last heartbeat of the universe before it learned to shine. Another whispered, almost afraid of the implication, "It is not a signal, it is a foundation." But the most chilling interpretation came from a mathematical cosmologist who had spent years studying the early universe. This rhythm does not come from motion, it comes from rule. A rule, a law embedded into space-time before photons existed. A law that, somehow, persists unchanged inside the starless zone. To understand the significance, imagine the universe in its first fractions of a second, a place without light, without particles, without separation, a boiling field of potential where forces had not yet specialized, where the quantum foam churned in superheated silence. In that world, before symmetry broke, before electromagnetism split from the unified forces, before light earned the right to travel, the universe pulsed, not with sound, not with energy, but with possibility. Somewhere in that primeval pulse lies the origin of every law that governs reality today. And inside the starless zone, that pulse may never have stopped. As more gravitational readings were collected, patterns began to form. Subtle variations in the pulse, frequencies suggested depth, as though the rhythm was layered. A slow beat, a faster, faint oscillation hidden beneath it. And a third, even more delicate vibration, detectable only with the most sensitive quantum sensors. 3 rhythms, 3 layers, 3 histories. The first pulse, steady and slow, traced the outer boundary. It shaped the edge of the starless zone like a drumhead stretched across the cosmos. The second pulse, subtle, soft, nearly imperceptible, flowed around the ring-like symmetry mapped earlier. It was not the ring that created the pulse. It was the pulse that maintained the ring. The third, the faintest, whispered only from the center, a fragile signature, as if the core itself was humming a very old song. These pulses did not interact. They did not reinforce each other. They did not combine or interfere. They coexisted, like the layers of an organism, like the harmonics of a vast, invisible instrument, like the breath of space-time learning to shape itself. And when the 3 pulses were plotted together, a pattern emerged, not random, not chaotic, but elegant. A standing wave, a resonance frozen across billions of years, a fossil of the first vibration reality ever knew. The moment researchers saw the resonance, everything changed, because standing waves require boundaries. They require confinement. They require structure, which meant the starless zone was not simply a pocket of primordial physics. It was an enclosed system, a chamber held together without matter, without force, without energy in the sense we understand it. A chamber bound by rule alone. The theory spread quietly, almost fearfully. The starless zone is a preserved cavity of pre-light space-time, a relic not of broken physics, but of ancient physics, a room inside the universe where the first laws still hold. But if it was a room, what kept it intact? What prevented entropy from dissolving it? What allowed it to survive 13 billion years unchanged? Some believe the cavity was topologically sealed, a knot in space-time that could not unravel without tearing reality itself. Others propose that the pulses were self-reinforcing, creating a stable equilibrium that preserved the interior. A few whispered the boldest idea of all. This cavity may not be a remnant. It may be maintained. Maintained by what? No one dared to answer. The mystery of maintenance grew deeper when researchers realized the pulses followed mathematical relationships that were not based on our universe's constants. The intervals between pulse layers did not match the Planck scale, did not align with the speed of light, did not depend on gravitational strength. they matched something else. Something that did not exist anywhere else in the observable cosmos. A constant of the pre-light era. A constant from before photons, before symmetry breaking, before space itself cooled enough to take shape. One cosmologist summarized it in a single line: these pulses are older than physics. And if the pulses are older than physics, then the cavity they define is older than reality. This is where conflict began to brew inside the scientific community. Not conflict of hostility, but conflict of comprehension. How do you study something that predates the instrument you study it with? How do you measure a rule that your own universe abandoned long ago? How do you interpret a structure that refuses to speak any language derived from light? The Starless Zone had no interest in helping. Even as more data came in, the cavity remained perfectly mute to photons, perfectly invisible to electromagnetic inquiry, perfectly sealed from any approach based on visibility. And so, scientists were forced to use the universe's quietest tools: gravitational waves, neutrino deviations, minute distortions in space-time curvature, tools that bend the knee to silence. As new measurements accumulated, a picture emerged of the cavity's internal shape, not in light, but in rhythm. The cavity was not spherical, it was not irregular, it was not chaotic, it was harmonic. A nested shell of resonance layers, each one vibrating at precise ratios, like the interior of an unlit instrument carved from the first seconds after the universe's birth. Some theorists proposed a name: the primordial well, a well where the first rhythm of reality remains trapped, a well where light cannot exist because illumination had not yet been invented when the cavity formed. Deep models showed that each resonance layer contained slight curvature, bends tiny folds in space-time, fractions of a millimeter over light years, so delicate they defied description. These folds resembled nothing known, not wave interference, not gravitational lensing, not remnants of cosmic inflation. They resembled the early mathematical models of pre-symmetry space-time, when the universe had no distinction between forces, when everything hummed in a single, unified frequency. Inside the Starless Zone, that frequency still lives. As the models improved, scientists noticed something even stranger. The resonance layers were slowly drifting inward, not collapsing, not fading, but shifting, as if the cavity were tightening its own structure very, very slowly. The rate was microscopic, far too small to detect except over decades. But the trend was real. The cavity was not static. It was adjusting, breathing, resonating with a purpose. The purpose became clearer when researchers noticed the drift synchronized with gravitational waves from distant cosmic events. A supernova on one side of the universe, a black hole merger on the other. Each produced barely measurable changes in the cavity's resonance layers. The cavity was listening, not to light, not to radiation, but to space-time itself. When gravity rippled across the universe, the cavity shivered, not in fear, not in disturbance, in recognition, as though it remembered those waves from a time before the universe cooled, a time when space-time was fluid, a time when reality itself oscillated. And as gravitational waves passed, the cavity responded: a faint tightening, a gentle recentering, a soft inward whisper. The more scientists studied the pattern, the more one terrifying idea grew impossible to resist. The cavity is adapting to the modern universe. Not rapidly, not aggressively, not intentionally, but instinctively, like a fossil shifting its weight in the earth, like an ancient organ responding to a heartbeat it does not recognize, like an echo adjusting to the shape of a canyon carved long after the echo was formed. And as the cavity adjusts, the pulses change, ever so slightly, ever so delicately, not enough to alter the rhythm, but enough to reveal a deeper structure, a hidden harmonic riding beneath the others. A fourth pulse. This fourth pulse was nearly impossible to detect. It lived far below measurable frequencies. in a domain where oscillation becomes meaning, where vibration becomes presence. When researchers finally isolated it, they realized it was not a pulse at all. It was a drift, a slow, continuous tilt in the curvature of the cavity's center, a tilt without energy, a tilt without motion, a tilt representing nothing we have a word for, except perhaps this, an intention, not of consciousness, not of purpose, but of persistence. The cavity persists because reality inside it is incapable of doing anything else. It is the memory of existence, a memory that does not age, does not dim, does not fracture. And now, as you drift deeper into the thought that this cavity might be the oldest intact structure in the universe, the question that physicists avoid rises quietly. If this cavity preserves the universe before light, what does the universe preserve inside it? The pulses continue, the resonance layers breathe, the fourth drift hums beneath everything, and the sense grows subtle, unspoken, steady. Something inside the starless zone is still holding on to the oldest rhythm reality ever made. The strange drift at the core of the starless zone should have been enough to occupy the scientific community for decades. Yet something else, something even more disquieting, soon began to rise from the data, a discovery not within the cavity itself, but in the space just outside it. Gravity was misbehaving, not violently, not chaotically, but unmistakably. It bent in ways no theory predicted, tilted in directions that made no cosmological sense, softened and sharpened with a precision that felt almost scripted. At first, the anomalies appeared as tiny deviations, variations so small they could be dismissed as instrumental error. But the deviations repeated, then multiplied, then aligned, across thousands of observations. From orbital interferometers to planet-based detectors, the same quiet truth revealed itself. Gravity near the starless zone was behaving as though the cavity were rewriting the curve of space-time around it. Not pulling, not pushing, rewriting. To see how subtle this rewriting was, imagine the gravitational field around a massive object, smooth, predictable, shaped by well-understood rules. Now imagine the tiniest of shifts in that field, like a breath warming the air around a stone. Barely noticeable, yet unmistakably intentional. That is what researchers saw. Tiny distortions that did not match mass distribution, did not match dark matter models, did not align with gravitational lensing simulations. They flowed. Gravity does not flow. Gravity curves. But here, near the starless zone, it felt like a tide, a slow, rhythmic rise and fall, synchronized with the pulses emanating from the cavity. The first suspicion was reflexive, instrumental drift. But drift does not coordinate across continents. It does not synchronize between sensors separated by millions of kilometers. It does not generate identical waveform signatures in detectors designed with entirely different methodologies. The truth was unavoidable. The starless zone influences gravity, and not through mass, not through density, not through energy, through rule. The cavity seemed to impose geometric constraints on space-time around it, constraints that bent gravity the way a sculptor bends clay, gentle yet precise. These constraints produced patterns researchers began calling gravitational veins, thin striations where the gravitational gradient shifted subtly, as if reality were folding itself around an invisible skeleton. The veins radiated outward from the cavity in slow, sweeping arcs. Arcs that followed no visible structure, obeyed no known force, and yet repeated with such fidelity they had to be real. What unnerved observers was how organic the veins felt, like tendrils, like roots, like the vascular traces of something old and sleeping. But the most disturbing part was this: the veins were moving, not in any way the human eye could detect, but over months and years, as data accumulated, the veins drifted, realigning, tightening, loosening in perfect synchrony with the cavity's interior pulses. A changing map, a living geometry. Gravity responding to rhythms older than light, Some theorists suggested the cavity was a gravitational resonator, a place where space-time oscillated at frequencies so old they predated the universe's current shape. Others believe the cavity was not emitting pulses, but interpreting them a relic, responding to gravitational events across the cosmos, the way a tuning fork resonates with sound. But as models improved, another theory emerged, a theory many feared to consider. The gravitational behavior near the cavity resembled not response, but influence. Influence from inside. Within the cavity, structures existed: gravitational contours, rings, folds, harmonics. And those structures, those primordial architectures, appeared to shape the gravitational field outside the cavity, as though the boundary did not fully isolate the interior, as though gravity, unlike light, passed effortlessly between universes. Gravity is the only force that couples directly to space-time geometry. The cavity is a geometry unrelated to ours, yet the two were touching, blending, reverberating. The closer sensors came to mapping this interface, the more one realization grew. The cavity does not simply reject light. It rejects the universe's geometry, and, in that rejection, it imposes its own. One physicist put it softly: it is not bending space-time. It is reminding space-time what it used to be. This reminder produced effects unlike anything ever recorded. For example, clocks placed near the boundary began to drift out of synchronicity, not significantly, not dangerously, but measurably. Time dilated in a gentle, rhythmic cycle, matching the cavity's pulse layers. Not faster, not slower, just uneven, as though time itself hesitated, echoing the ancient rhythm that existed before chronology settled into the smooth flow we know. At first, the dilation was thought to be noise, but as more atomic clocks were deployed around the region, the pattern grew undeniable. Time near the cavity wavered, not randomly, not chaotically, in harmony. A harmony older than causality, older than direction, older than before and after. Inside this harmonic zone, gravitational veins twisted subtly, microscopic bends in curvature that spiraled outward like the ripples of a stone thrown into a lake that has forgotten how to be water. These spirals were not chaotic. They followed equations that did not appear in modern physics, equations resembling the mathematics of early universe models, where space-time existed in a fluid phase. One researcher whispered the phrase, pre-geometric flow, and though no one wanted to admit it, the words fit. Gravity was flowing, not bending, not exerting, but flowing. Flowing the way primordial space-time once did, before it solidified into a rigid fabric, before the cosmic web stretched itself thin, before structure began choosing shapes. Some cosmologists asked quietly whether the Starless Zone contained a sample of that fluid state, a piece of the universe before geometry crystallized. But even among such theories, one anomaly stood apart. A feature so subtle and yet so impossible that it forced everyone to reconsider what gravity even means inside this context. The cavity appeared to have a preferred direction, not a vector, not a force line, but a gravitational orientation, a faint tilt in the way curvature arranged itself, aligning every resonance and vein toward the cavity's center. This preference had no counterpart in astrophysics. Gravity has no direction of preference. It responds to mass, to energy, to curvature. It does not align itself. But here, gravity leaned, like water leaning toward a deeper well, like a tide leaning toward a distant moon, like meaning leaning toward origin. This lean suggested something extraordinary. Inside the cavity, there may be a deeper minimum, a place where the earliest form of space-time settles, a cradle of pre-light physics. It is not a point, not a location, not a singularity. It is an attractor, a rule toward which the entire cavity orients. If the Starless Zone is a preserved chamber of primordial reality, then this attractor may be its anchor, the place where the first rhythm of the universe rests. And that rhythm, that gravitational hum, did something else no one predicted. It accelerated matter. Tiny particles drifting near the cavity began to speed up, not toward the cavity, but along the gravitational veins. Each particle traced the pathway like dust carried by a silent current. Even dark matter simulations showed the same effect, a faint migration along the veins' structure, meaning the veins were not simply patterns, they were conduits of rule. Conduits that shaped the movement of matter across vast distances in ways entirely unknown. And so, the question deepened. If matter follows these veins, what do the veins follow? The answer emerged not from physics, but from rhythm. The veins aligned perfectly with the pulses, just as a river aligns with the slope of its bed. And the pulses aligned perfectly with the cavity's internal resonance. A trinity of influence. The cavity resonates. The pulses shape gravity. Gravity carves the veins. Together they form a system, a living, breathing system, the oldest surviving pattern of existence. Not life, but order. Not intention, but persistence. Not creation, but memory. And as you drift deeper into this unfolding logic, you begin to sense that gravity itself is acting as a messenger, a bridge between two regimes of reality, the illuminated universe and the pre-light universe preserved inside the Starless Zone. The deeper researchers mapped the interface, the more the gravitational distortions resembled communication, not in deliberate signals, but in the way the cavity responds to events far beyond it. Distant black hole mergers, neutron-star collisions, cosmic strings vibrating in unreachable voids. Each cosmic event sent gravitational tremors across the universe. Each tremor caused the cavity to pulse in reply, a faint shift, a soft contraction, a subtle harmonizing of its layers. The cavity was not just responding, it was remembering. Gravitational waves carry history, the memory of events so massive they deform space-time itself. And the cavity, bound to the oldest rhythm of reality, seemed to absorb these memories, not to change, not to grow, but to maintain resonance with the universe that evolved outside it, like an ancient instrument, still humming along with a song it cannot see. And in that humming, a realization surfaces, soft, slow, inescapable. The Starless Zone may not be a remnant of an ancient universe. It may be the universe's first rhythm, still beating. A place where geometry has not aged. A place where gravity remembers its childhood. A place where existence has preserved the moment before illumination began. And somewhere in that preservation, somewhere in the way gravitational veins twist toward the cavity's center, there is the faintest suggestion that something inside the Starless Zone might still be shaping the universe, quietly, patiently, through the only force that can cross its boundary, gravity. Gravity born from a physics older than physics, moving through a space older than space, carrying a rhythm older than light. A rhythm the cabin of darkness continues to breathe, slowly, steadily, unchanged across cosmic time. As gravity continued to whisper its ancient rhythm into the fabric surrounding the Starless Zone, researchers turned their attention back to something even more delicate, something that first surfaced in the earliest observations, long before gravitational veins were mapped, long before the cavity's layered pulses were understood, the unraveling, that brief, impossible moment when photons, the universe's most obedient messengers, forgot how to be themselves. At first, the unraveling was a curiosity, a faint flicker in a magnified waveform, a quirk, a stutter, a hesitation. But as instruments improved and recordings multiplied, the hesitation grew unmistakable. Photons approaching the Starless Zone did not die. They did not collide. They did not scatter. They unraveled. Unraveling is not annihilation. Annihilation leaves heat. It leaves products. It leaves evidence. Unraveling leaves nothing. It is the quantum equivalent of a sentence dissolving midward. as if grammar itself evaporated. The photon's frequency wavers, its phase fractures, its identity loosens, like thread pulled from ancient cloth. This unraveling begins far earlier than expected, not at the boundary, but in the space just outside it, in a thin region where the laws of electromagnetism begin to soften. A region researchers began calling the quantum penumbra. If the pre-null halo described a gravitational shift, the quantum penumbra described a cognitive one, the moment where the quantum rules governing light begin to lose their authority. Inside this penumbra, nothing violent happens. No heat spike, no energy surge, no quantifiable stress. The photon simply begins to question its own structure. What makes a photon a photon? Its frequency, its phase, its coherence, its interaction with charged particles. Inside the penumbra, each of those characteristics begins to drift. At first, the drift is microscopic picoseconds of phase misalignment, tiny fluctuations in wave curvature. Then, as the photon moves deeper, the drift accelerates. By the time it reaches the true boundary, the photon no longer has a stable wave function. It has lost the definition that allowed it to exist in the visible universe. The realization that photons question their identity near the starless zone shook the foundations of quantum physics. Because photons do not question, they obey. Their uniqueness lies in their constancy. They do not age, they do not slow, they do not decay. But inside the quantum penumbra, they decay without dying. They lose coherence without scattering. They forget themselves without ceasing to exist. A paradox, a silent one. To model the unraveling, researchers built quantum field simulations, but none behaved correctly. They either annihilated the photon prematurely or allowed it to pass through unchanged. The real phenomenon did neither. It unmade without violence. One theorist suggested the region was not killing photons, but stripping them of meaning, the way a word spoken without context becomes mere sound. If light has no definition here, one physicist whispered, then what is a photon inside this region? A possibility without the rule that gives it shape? Possibility without rule, a dangerous idea. It implied that inside the cavity, quantum fields exist in a state before division, before electromagnetic interaction separated itself from the unified forces of the early universe. To understand this, imagine the cosmos at an unimaginably early age when forces were not yet distinct, when light had not yet been assigned a role, when the universe was a single, shimmering field of potential. In that age, particles did not exist. They emerged only after cooling fractured the symmetry into familiar forms. But the starless zone appears to preserve this unfractured regime. Inside it, photons cannot exist because the rule that defines photon has not been written. The quantum penumbra is the margin where existence negotiates with forgotten laws. It is the edge of a script rewritten billions of years ago, yet still alive in this one place. As more data emerged, something stranger arose, a pattern in the unraveling. Photons with higher frequencies unraveled sooner, as if the cavity rejected certain energies more aggressively than others. Low-energy photons, radio waves, microwave bands survived longer before dissolution. Higher-frequency photons, ultraviolet, X-ray, gamma, collapsed much earlier, as though the cavity recognized them first. Recognition, a difficult word in physics. Yet the unraveling was not random. It had order. It followed rules. Frequencies dissolved in a sequence that mirrored the timeline of the early universe. High-energy photons, those associated with the violent infancy of creation, were unmade far from the boundary. Lower-energy photons, those associated with the age of cosmic cooling, survived until they reached the very edge. This pattern was unmistakable. The cavity filtered light by age. Not chronological age, conceptual age. The starless zone rejected the youngest forms of photon definition first and the oldest last, as if tracing electromagnetism back through its evolutionary stages. This was not simply physics. It was archaeology. The unraveling became a map, a reverse timeline of light's history. By studying where each frequency dissolved, scientists could reconstruct the phases of photon development from the first moments after symmetry breaking all the way to the modern universe. The cavity, without speaking, was telling the story of illumination backward, and as the unraveling grew more defined, a disturbing symmetry began to appear. The unraveling matched the cavity's internal pulses. Each resonance layer deep inside the cavity corresponded to a stage in the unraveling outside it. It was as though the cavity were teaching the universe how it once behaved, demonstrating the rules of a time when photons had no authority. This connection was first suspected when quantum sensors noticed a faint rhythmic oscillation in the uncertainty of photon wave functions, an oscillation synchronous with the cavity's gravitational heartbeat. The two rhythms, gravitational and quantum, were aligned. This should not be possible. Quantum fields and space-time curvature do not synchronize on their own. They operate on different scales, different frameworks, different assumptions. Yet near the starless zone, they moved in harmony. One physicist said quietly, "Gravity is shaping the quantum field here." Another said, "No, the quantum field is remembering gravity's old form." And a third, her voice barely audible, whispered what no one wanted to admit. The cavity is imposing pre-light quantum rules. These rules manifested in more than unraveling. Particles that drifted into the penumbra, electron neutrinos, muons, even stray cosmic rays, experienced subtle shifts in their wave function stability. Not enough to break physics, but enough to reveal the presence of a deeper pattern. Wave packets stretched, flattened, and lost coherence along trajectory paths that traced the gravitational veins. Quantum uncertainty elongated in the direction of the cavity's internal rhythm. No randomness, no chaos. A choreography, as if the cavity were a conductor, and quantum fields were instruments forced to follow the oldest tempo ever played. Some researchers used the term proto-quantum regime, a hypothetical state where quantum fields had not yet differentiated into the separate interactions known today. Inside the penumbra, that regime seemed partially restored. Wave functions behaved like they did before light existed, fluid, unbound, unconstrained. The unraveling, then, was not dissolution. It was regression. A photon approaching the boundary returned to a state older than photon identity, older than the concept of brightness, older than the idea of visibility. It dissolved back into possibility. As models improved, another stunning revelation emerged. The unraveling followed not a single dimension, but a curved manifold, a mathematical surface that spiraled gently around the boundary, shaped exactly like the cavity's interior resonance. The quantum penumbra was not a region, it was a path the photon followed as it regressed into pre-light potential. This path wound around the boundary like the trace of a forgotten symbol, a geometry written before geometry had form. As the photon moved along the path, its coherence shifted, its uncertainty inflated, its identity softened, until it reached a point where the universe no longer recognized it. And at that moment, the photon did not die. It simply rejoined the cavity's rhythm, the rhythm that predates light, the rhythm that shaped gravity, the rhythm that the universe abandoned when visibility emerged. In that sense, the starless zone is not rejecting light, it is reclaiming it into a state where illumination is unnecessary, where existence expresses itself without brightness, where the universe speaks not through photons, but through the quiet curvature of possibility. And as researchers trace the unraveling path deeper, one last discovery cast a shadow over everything they thought they understood. The quantum penumbra reacted, not to photons, not to particles, but to gravitational waves. Whenever a cosmic event rippled space-time, the death of a massive star, the collision of neutron cores, the penumbra shifted slightly, as though tightening or relaxing in response, which meant this boundary, This shell between worlds was alive in the only way ancient physics can be alive. It listens. It listens to the universe outside, not with light, not with energy, but with rule. And when it listens, the penumbra adjusts, changing the unraveling path, reshaping the margins of possibility, as though calibrating itself to stay consistent with a cosmos that no longer resembles the world that birthed it. As you drift into that thought, the image of a boundary listening to gravity's stories, a cavity breathing the first rhythm the universe ever made, the penumbra begins to feel less like an edge and more like a memory. A memory being rewritten each time reality trembles. Yet even as it shifts, its purpose remains unchanged: to unmake light back into what it was before illumination existed. And the universe, still expanding, still brightening, still igniting billions of suns, cannot alter that purpose, for the Starless Zone is not part of the illuminated universe at all. It is part of the one that came before, and somewhere within that pre-light quiet, in the cadence of unraveling wave functions and the hum of primordial resonance, lies the faint suggestion that this cavity was never meant to be seen, because the universe itself was once shaped in darkness. For months, researchers circled the same impossible conclusion without daring to name it. The evidence had been growing quietly, threading itself through every dataset. The gravitational veins aligning with primordial rhythm, the quantum unraveling following an ancient sequence, the cavity's pulses resonating with early universe mathematics. Everything pointed toward a single idea, one so unsettling, so disruptive, that no one wanted to be the first to write it down. A hypothesis so old it felt new, so simple it felt dangerous. The Starless Zone might not be an anomaly. It might be a preserved snapshot, a fragment of the universe, not from another place, but from another time. Not a remnant of exotic matter, not a dark energy disturbance, not a rupture between dimensions. A preserved moment, a pocket of the cosmos still existing in the physical regime that dominated the universe before light. For months, the idea circulated only as a whisper, spoken in corridors, scribbled in margins, avoided in formal meetings. Even the boldest physicists resisted it, not because it broke physics, but because it restored physics to a state we believed long lost. To understand why the idea terrified them, imagine the universe at the dawn of existence. Not the bright explosion popular imagination clings to, but the true earliest era, the first trillionths of a second, when everything was compressed into a roiling, opaque ocean of energy. Light existed, but it could not travel. It was trapped, bound, smothered inside a dense plasma so thick photons bounced endlessly, imprisoned by the young geometry of space-time. During that era, there was no transparency, no color, no seeing, only pressure, heat, and potential. Then came the great transitions: symmetry breaking, cooling, the emergence of forces, the birth of matter. Gradually, light learned to move. The universe learned to illuminate itself. But if the Starless Zone is truly a preserved region of that pre-light era, then it is more than a fossil. It is a piece of the universe's childhood still living, a place where the transition never completed, where photons never gained freedom, where the laws of that early epoch remained sealed, protected, untouched. A snapshot, not preserved by accident, but locked in place by topology, the shape of space-time itself. This possibility explains everything: the unraveling, the gravitational rhythm, the resonance layers, the cavity's stability, its indifference to entropy, its ancient behavior. It is not that the cavity resists change. It never underwent change. It simply continued being what everything once was, a preserved echo of the universe before visibility. But articulating that idea in a scientific context felt sacrilegious. It meant the universe was not homogeneous, not consistent, not uniform across time. It meant the early cosmos left behind scars, pockets of untouched rules, It meant time did not move forward everywhere. And if time did not progress uniformly, then the universe does not simply expand, it fractures. Not physically, but historically, not in space, but in rule. The reluctance to publish the idea was understandable. No researcher wanted to be accused of resurrecting ancient cosmological myths, theories about primordial domains, regions of frozen time, the first darkness. Yet the data carried its own quiet insistence. One by one, the pieces converged. First, the cavity's gravitational rhythm. Its steady pulse matched early universe models for space-time oscillation before the electroweak phase transition. Second, the unraveling sequence. Photons dissolved in reverse order of their historical emergence. High-energy photons first, lower energy last. A perfect retracing of illumination's origin. Third, the resonance layers. The concentric shells matched theoretical structures predicted for the earliest fluid state of space-time before geometry stabilized. Fourth, the boundaries' selective silence. Only electromagnetic phenomena were erased. Gravity passed through easily. This is exactly how the infant universe behaved: opaque to light, transparent to curvature. Fifth, the cavity's stability. 13 billion years of cosmic chaos, yet it remained untouched. Not resisting entropy, but existing in a physical regime where entropy did not yet operate like it does today. Piece by piece, line by line, measurement by measurement, the truth sharpened. The Starless Zone is a domain where the early universe still exists, but not as a recording, not as a simulation, not as a memory, as itself, still functioning, still pulsing, still holding the rules of a world before illumination, a living snapshot, a preserved epoch, a pocket of time that did not move forward. When the first internal technical memo finally acknowledged this theory, the language was cautious. Data suggests the region may represent a non-evolved solution of the early cosmos. But those reading it knew what the words truly meant: a non-evolved solution, a place frozen not by cold, but by rule. Later, memos grew bolder. One referred to the cavity as a proto-era remnant, another as a preserved pre-transparency domain. A third, written late at night by a cosmologist who had spent half her life studying the first microseconds of the universe, used the phrase no one expected to see in a formal document, a pocket of cosmic infancy. And yet, even as the hypothesis spread, it carried with it a gravity darker than the cavity's silence. Because if the Starless Zone preserves the early universe, then we are staring at something far stranger than a relic. We are staring at an era that never ended. Somewhere deep inside that unlit chamber, the cosmos is still young, still pulsing with the first rhythm, still humming the melody of unified forces, still carrying the rules of a world that collapsed into transparency everywhere else. If this is true, the Starless Zone is not an artifact, it is a survivor of the moment before the universe made light possible. And survivors always raise questions. Why did this region remain? Why here? Why not everywhere? What conditions prevented its evolution? What properties preserved its primordial state? Some theorists argued that the cavity sits at the intersection of ancient cosmic defects, topological scars left from the universe's earliest expansion. Such defects could create sealed pockets of pre-light rule, trapped inside topological knots that cannot unravel. Others believe the cavity formed because of fluctuations in early vacuum energy, a region where the phase transition simply failed, leaving behind a bubble of pre-electromagnetic reality. But the boldest theory, the one whispered with caution, was that the cavity is not a failure of transition. It is the origin of transition, a seed, a place where the early rules were written, a chamber where illumination was born, a womb of physical law itself. If that is true, the cavity is not an exception. It is the prototype. The universe may have expanded and illuminated, but the place where those laws were forged remained untouched, preserved like a still-lit kiln inside a dark temple. A physicist studying early-phase quantum cosmology wrote the line that crystallized this idea. The starless zone might be the place where the universe first decided what it would become. And that decision, the shaping of forces, the definition of photons, the molding of geometry left behind the cavity as its original form. If the cavity is indeed that place, then its existence is more than a mystery. It is a blueprint of creation, and perhaps more than that, a boundary between what existed before and what exists now. A seam in time, not a time machine, not a portal, but a preserved surface between eras. The presence of a preserved surface raises an even more delicate question. If the starless zone is a snapshot, does it still evolve according to ancient rules? And if so, what does evolution mean inside of physics that predates light? Here, gravitational readings offered the first clue. The cavity's core drift, the slow, almost imperceptible tilt, appears to be the ancient rule expressing itself in modern spacetime. A rule adapting, adjusting, responding to gravitational waves from the current universe. This means the snapshot is not static. It is alive in its own way, not biologically, but rule biologically, organizing, adapting, preserving. Early models suggested that if the cavity does evolve, it might be converging toward a new equilibrium, not the equilibrium of modern physics, but of its own regime. A place where time has qualities we do not understand, where causality obeys unfamiliar mathematics, where the pulse of existence does not move forward, but inward. Toward what? This became the central question. What lies at the core of the preserved epoch? What sustains the rhythm? What gives the cavity shape, structure, identity? One theorist proposed something provocative. Perhaps the cavity preserves not the early universe, but the memory that the early universe had of itself. Memory as physical structure, memory as curvature, memory as resonance. A memory untouched by time, because time itself is different inside it. Another proposed that the cavity might contain the seed of symmetry, the original unified field that split into the four forces we know today. If that seed is preserved, it would be the oldest object in the universe, not matter, not energy, but rule. But even these theories felt incomplete because they did not address the real question everyone avoided. If the starless zone is a preserved era, did the universe preserve only one such pocket? Or are there others scattered across the cosmic web, hidden in voids, tucked between filaments, each a chamber of forgotten physics? If so, we may be living in a universe with ancient organs, organs that never evolved, organs that hold the memory of what existence was before illumination. And if the universe carries such organs, what purpose do they serve? Are they inert? Are they active? Are they waiting? Are they part of something larger? A structure spanning multiple preserved pockets? Some scientists believe the cavity may be one node in a web of primordial domains, each holding a different aspect of pre-light physics. Others believe it is unique, a solitary survivor, but the starless zone does not answer. It only pulses, silently, patiently, as it has since the moment before time understood brightness. And somewhere in that pulse, in the quiet, rhythmic breathing of a physics that predates visibility, there is the faintest suggestion that the universe is older than the version of it we see, older in ways we do not yet have language for, older in rules we no longer use, older in memory we barely recognize. The cavity is not a scar, it is a witness to the beginning. And as the gravitational rhythms continue to press outward, as the quantum penumbra continues to unmake photons, as the boundary continues to hold its precise, ancient stillness, one truth rises from the dark like a gentle exhale. The starless zone is not showing us the past. It is showing us the part of the universe that never left it. The more the evidence accumulated, the more the starless zone began to feel less like a place and more like a moment that refused to die. A preserved fragment of the universe's first breath, still vibrating, still humming, still carrying a cadence older than light itself. But for all the gravitational murmurs and quantum unravelings, for all the layers of resonance and the perfect silence carved into the cavity's heart, there was still one thing missing: a proof. A sign that what we were seeing wasn't just a coincidence of curvature, a rare vacuum anomaly, or a sculpted byproduct of cosmic expansion. A sign that the starless zone truly belonged to the universe, before illumination, before color, before transparency. That proof arrived quietly, not in the form of light, light cannot touch the region. Not in the form of matter, matter is indifferent to it. Not in the form of heat, magnetism, charge, or field. It arrived as a whisper, carried by the most patient messenger the cosmos ever made: the cosmic microwave background. The CMB is the universe's oldest memory, the afterglow of the moment the cosmos became transparent, a faint hum of photons stretched thin by billions of years of expansion. It touches everything. It surrounds everything. It is the faint light that fills the night even when no stars shine, and it avoids nothing except the starless zone. When researchers layered CMB maps over the cavity's position, something curious emerged: a softness in the radiation's texture, a thinning in its otherwise omnipresent glow. A place where the CMB's temperature dip looked wrong, too orderly, too calm, too smooth. The CMB should not smooth out around a void. Voids distort it, clusters distort it, everything distorts it. But the cavity did not distort the CMB. It erased it. Not cold, not hot, not warped, erased. A subtraction that left behind no explanation, no mechanism, just a simple, impossible absence in the oldest light of the universe. The first scientists to notice this anomaly stared at the map for hours, rerunning calibrations again and again, hoping the absence would shift, fade, crack. It didn't. It was perfect. Too perfect. A smooth oval carved into the universe's earliest light, a shape so geometrically clean it could not be the result of gravitational lensing or foreground interference. This was something else. A silence inside a silence. A hole in the universe's memory. A place where the past refused to touch the present. Even more unsettling was the CMB's behavior near the boundary. Rather than bending, scattering, or wobbling, the CMB's photons showed a faint rhythmic wobble, not imposed by the cavity, not caused by its curvature, but matching the cavity's internal pulse. In other words, the oldest light in the universe was trembling to the rhythm of the oldest darkness. This was the first true echo, a resonance so faint that even the most sensitive detectors captured it only after months of integration, an almost musical alignment between the universe's earliest illumination and the cavity's preserved silence. As the data sharpened, physicists realized they were looking at something impossible. The cavity was imprinting its own pulse onto the cosmic microwave background, not through energy, not through scattering, through rule. The CMB is a map of what the universe looked like when it was only a few 100,000 years old, still young, still hot, still ringing with the echo of the Big Bang. But inside the cavity, the universe was even younger. So young that light had not yet been released. And here, surrounding the cavity, the CMB was being forced to synchronize with that earlier rhythm. The effect was tiny, but unmistakable. Each time the cavity pulsed, the CMB dimples around it tightened, as though adjusting their shape to honor a tempo the rest of the cosmos had long forgotten. It was like listening to a choir and hearing one ancient voice singing a different melody, a melody older than the song itself. That ancient voice was the cavity. This was the moment the mini-climax of the entire first arc arrived. Because once researchers isolated this rhythmic correlation, another pattern surfaced. By filtering the CMB data through a series of harmonic extractions, they uncovered a faint, repeating signature, a modulation in the most ancient light that matched the predicted oscillation of space-time before photons existed. A signature no one expected to ever detect. A signature from the time before the universe had color. Color is not an intrinsic property of objects, it is a property of light. It requires photons. It requires wavelengths. It requires the ability of the universe to shine. But the signature found in the CMB around the cavity belonged to a time before any of that existed. A time when the universe was a single, opaque ocean of energy, and the only rhythm was the one that shaped the forces to come. The cavity's pulse matched that rhythm exactly. This was not coincidence, not pattern finding, not interpretation. It was a match. The cavity's internal structure pulsed at the same frequencies predicted for space-time oscillations before the electroweak epoch. In other words, the cavity is vibrating like the universe did before light was possible. It's not mimicking it, it is living it. A physicist who had spent her entire career studying early universe transitions wrote in her private notes, "I feel as though we have found the universe's first voice, not metaphorically, literally. A vibration older than illumination, older than matter, older than time as we measure it." Some suggested the cavity might be a fossil. Others believed it was still active. But one interpretation whispered between researchers felt truer than the rest. The Starless Zone is not a remnant. It is a preserved state of the universe's first, second, a living museum of what came before. And now, through the trembling of the CMB, the universe itself was answering the cavity. Illuminated time responding to pre-illumination time. Two eras speaking across billions of years. The present listening to the past pulsing into the present. A bridge built not with matter, nor light, nor energy, but with rule. As analysts deepened their study of the echo patterns, they found something breathtaking. The modulation of the CMB was not simply synchronized with the cavity. It was layered. 3 faint harmonic bands matching the cavity's 3 main pulses appeared in the filtered data. The CMB carried the melody. The cavity carried the rhythm. Together they formed a harmony between the universe that shines and the universe before shining existed. It was as though the cavity reached out across the ages and touched the oldest light ever produced, reminding it of the time when illumination first began to break free. But the fourth modulation, the one matching the cavity's slow drift, did not appear. The CMB did not echo that one. Why? Because the fourth pulse belonged to something deeper, something the universe itself no longer remembers, something older than the CMB, older than transparency, older than the moment photons were free, something belonging to the universe before time had color. The fourth pulse remained silent in the CMB, carried only by gravity, only by curvature, only by the deepest folds of spacetime, a signature older than memory. And as scientists realized this, another truth settled in. If the cavity preserves the universe before illumination, then the fourth pulse must be the rhythm of something even earlier, the rhythm of the universe before the first transitions happened, before forces differentiated, before space-time cooled into its modern form. The fourth pulse was a whisper from a moment so ancient that even the universe's oldest light could not answer it. No color, no wavelength, no glow, only rule, only shape, only possibility. The echo found in the CMB was therefore incomplete, a partial memory, the part of the early universe that survived illumination. The cavity held the part that did not. And in that contrast, in the tension between what the universe remembers and what the cavity preserves, the real mystery deepened. Because the cavity was not fading, not weakening, not eroding, it was strengthening. Each time a gravitational wave passed through it, each time space-time trembled with the memory of some distant cosmic event, the cavity pulsed a little more clearly. Not louder, not stronger, just clearer. As though the modern universe were tuning it, the way a musician tunes a forgotten instrument by playing nearby. the idea spread quietly among researchers. The starless zone is updating, not evolving, not adapting, updating. Updating its preserved rules to stay coherent inside a universe that no longer matches its physics. This frightened everyone, not because the cavity was dangerous, but because it was alive in the only way ancient physics can be alive. It remembers, it listens, and it responds, not with awareness, not with intention, with persistence. As the gravitational vanes tightened slightly in response to a recent distant black hole merger, and as the CMB echoes shifted their modulation by the smallest imaginable fraction, one truth became harder to ignore. The cavity is not merely a snapshot. It is an ongoing moment, a part of the universe where the first second never ended, a place where light still waits to be invented, a place where time is still choosing its shape, and somewhere in that preserved moment, in the quiet, ancient, patient pulse, there might be the first hint of why the universe needed illumination at all. There is a moment in every line of inquiry where the questions stop orbiting the data, and the data begins orbiting a single question. For months, researchers had been assembling the puzzle, the gravitational vanes swirling around the cavity, the quantum penumbra unmaking photons, the resonance layers drifting inward in slow, ancient harmonies, the CMB echoes responding like a faint, trembling choir, the fourth pulse whispering from a time even light cannot remember. Each new measurement drew the same silent contour, a shape older than visibility, older than transparency, older than illumination. A shape the universe seemed to hold on to as if it were the memory of what existence once meant. The question that rose from this was not a conclusion. It was a turning, a slow, careful turning of thought, a turning toward a possibility no one had allowed themselves to consider openly. What if darkness is not the absence of light? What if darkness is the original state of reality? Not darkness as shadow, not darkness as void, not darkness as fear, darkness as rule, darkness as law, darkness as the condition under which all things first existed. Light, in this view, is not the default. It is the anomaly, a late invention, a newcomer to the cosmic script, a sudden voice in a choir that had been singing long before illumination learned how to harmonize. If this is true, then the starless zone is not a mystery. It is a baseline, a place where reality behaves as it did in the beginning, where the rules are untouched by the later decision to allow brightness, where the geometry of existence has not been stretched thin by eons of stars, a place where the original physics still breathe. This line of thinking did not appear suddenly. It formed slowly, accumulating over thousands of observations, as if the universe itself were nudging humanity toward this realization. Light unravels because it is foreign here. The cavity pulses because ancient geometry still lives here. Gravity flows because it remembers the world before curvature froze into modern form. Everything about the starless zone aligns with a reality that predates illumination. And so the question sharpened. If this is the original state, then why did the universe ever choose light? The question hung in the minds of every cosmologist studying the cavity. Not because they lacked answers, but because the answers challenged the deepest assumptions of modern cosmology. The universe did not choose anything, of course, but its evolution contained a moment when the physical laws allowed photons to become free, a moment when darkness stopped being the only state, a moment when visibility emerged. This was not the beginning of time. It was not the start of existence. It was simply the moment the cosmos learned how to reveal itself. But the starless zone suggests something profound. The universe did not illuminate uniformly. Some regions remained sealed inside the original rules. Some pockets refused the transition. Some domains, by topology, by timing, by curvature, stayed the way the universe once was. And the starless zone may be the largest preserved pocket ever found. If the cavity is truly a preserved regime of pre-light physics, then its existence forces a new perspective on the origin of reality. Not a universe born bright, but a universe born blind. Not a universe filled with stars, but a universe filled with potential. Not an illuminated cosmos, but a dark ocean waiting for illumination to happen. It challenges everything we think we know. Because in the illuminated universe, light defines truth, light defines location, light defines reality itself. But inside the starless zone, none of that matters. Inside the cavity, truth is defined by curvature. Location is defined by resonance. Existence is defined by rule. Light is irrelevant. As researchers dug deeper into this turning point, they realized the starless zone is more than a relic. It is a counter-universe, a place where the illuminated cosmos has no authority, where the physics we trust, the physics we believe is universal, simply does not apply. This created an intellectual conflict that tore through every department analyzing the region. If the starless zone is a preserved piece of the pre-light universe, then the illuminated cosmos is not the full story. It is a layer, a veneer, a chapter superimposed on something older. This does not diminish the universe we know. It deepens it. It suggests the cosmos carries its own history, not only in matter, not only in fossils, but in untouched pockets of rule. The starless zone is not a mistake. It is an archive with a pulse. The pulse itself grew more significant as scientists recognized its implications. The cavity's rhythm does not match any modern cosmic structure. It matches the predicted oscillation period of space-time just after inflation, when the universe was hot, dense, and blind. In that era, before light traveled freely, space-time vibrated with a steady frequency, a frequency determined not by photons, but by geometry itself. Everything, forces, fields, potential, oscillated in harmony. And now, billions of years later, that same harmony beats inside the cavity, a rhythm unbroken by time, a rhythm untouched by illumination, a rhythm remembering a universe that never needed to be seen. The turning point deepened when researchers mapped the gravitational veins again and realized they were not random. They traced a pattern identical to simulations of the early universe's energy gradients, not star maps, not dark matter filaments, early universe structure. The veins were not carved by modern gravity. They were carved by ancient conditions that have not existed elsewhere for 13 billion years. Inside the cavity, the universe has not aged. Its structure is still singing the first song reality ever made. And outside the cavity, that song is still shaping gravity, still tugging on space-time, still whispering to the universe that illumination is the exception, not the rule. This realization sparked the first philosophical debate of the entire project. Is darkness the true nature of the cosmos, and light merely a temporary phase? The debate was not metaphorical, it was mathematical. Everything suggested the illuminated universe is younger, more fragile, more conditional than the darkness that preceded it. Inside the cavity, there is no transparency, no visibility, no color, no photons, but there is structure, order, rhythm, meaning, geometry, a functioning physics, just one built from a different foundation. It made some scientists wonder, if the universe had never cooled enough to free photons, would illumination ever have occurred? Was light inevitable? Or was it an accident, a brief moment of clarity in a cosmos that prefers to remain unseen? The starless zone does not answer. It only pulses. But the pulse feels like an answer. Slow, steady, dark, the oldest rule, beating beneath everything. The turning point completed itself when researchers noticed something else. The cavity's internal structure did not drift randomly when gravitational waves passed. It drifted inward, toward the center, as though the cavity were focusing itself, coalescing, returning to the shape it held at the dawn of existence. This focusing contradicted everything we know. No structure should naturally move toward more order. Entropy pulls systems apart, but the cavity was moving toward order, not a collapse, a refinement, a perfecting. The illuminated universe expands, spreads, dissipates. The cavity contracts, tightens, remembers. Two opposite motions, one of aging, one of preservation. Two realities moving in opposite directions through time. And in the quiet tension between them, one idea becomes impossible to avoid. Perhaps darkness is not only the original state of reality, perhaps it is the final one. Not destruction, not collapse, not extinction, but return. Return to coherence, return to rule, return to the rhythm that existed before the universe sought to reveal itself. If light is the story, darkness is the page it is written on, and the starless zone may be the one place in the cosmos where that page remains unturned. As you drift into the thought, the cavity's pulse echoes once more softly, steadily, a heartbeat older than illumination, older than color, older than the idea of time moving forward. A pulse reminding the universe what it once was and what it may one day become again. The deeper researchers mapped the starless zone, the more one realization quietly emerged from the noise. The cavity possessed geometry, not the visible geometry of galaxies, spirals, arcs, or filament structures carved by light and matter and heat, but a geometry that did not require illumination to exist. A geometry made only of curvature, of rhythm, of how space itself pressed against itself. The first hints of this structure came from the gravitational veins, those slow, drifting striations that twisted gently toward the cavity's center, like streams converging into a silent lake. At first glance, they seemed random, but they weren't. They followed ratios, frequencies, alignments, far too delicate to belong to chance. Then came the resonance layers, concentric shells, each beating with its own tempo, yet perfectly synchronized with the ones above and below. When placed into simulation, these layers formed shapes, not spheres, not ellipses, but something more complicated, a manifold, a curved, smooth space that existed not within 3 dimensions, but within the deeper rules underlying those dimensions. Scientists attempted to visualize it, but every rendering felt incorrect, too rigid, too Euclidean, too dependent on the assumptions of an illuminated universe. Inside the cavity, geometry does not look like anything. It behaves. And so the first true models of the cavity structure were not images, but equations. Equations that described how distances stretch, how angles bend, how time responds when illumination is not part of the rule set. From these equations emerged a structure both alien and familiar, a geometry built from relationships instead of shapes. In our universe, geometry relies on points, lines, surfaces, angles, but in the cavity, none of these existed the way we know them. Nothing was defined by light. Nothing was anchored by visibility. Then what defined structure? The answer emerged from the pulse. That slow, ancient rhythm, the heartbeat of the cavity, was not simply an oscillation. It was the governing principle of distance itself. Where the pulse slowed, space stretched. Where the pulse tightened, space drew inward. Where the pulse remained perfectly steady, the geometry of the region froze into place. In a universe without light, distance is measured in rhythm. This realization placed the cavity into an entirely new framework. Its geometry was not spatial, it was temporal, a landscape sculpted by the beat of a reality older than photons. As researchers traced the pulse deeper into the cavity's theoretical interior, they found patterns, curvatures forming, petals, folds forming spirals, long arcs where the geometry curved back upon itself, as though tracing forgotten symbols in the dark. No one could describe these shapes directly. No eye could see them. No camera could record them, but gravity felt them, time felt them, Quantum fields felt them. From those reactions, a picture began to form, not of objects, but of relationships. Inside the starless zone, geometry seemed to follow three principles. First, symmetry, without visibility. Not symmetry of shape, but symmetry of behavior. The way pulses repeated, the way veins aligned, the way resonance layers reinforced each other. Second, distance, without light. Space did not measure itself by travel, but by the delay between pulses in the curvature, a universe defined by time rather than space. Third, form without matter. No particles shaped the cavity's interior. No mass defined its contours. No energy sculpted its edges. Only rule, a geometry born of rule. Some called it a dark manifold. Others preferred pre-light topology. But one researcher, studying the resonance equations late into the night, gave a more poetic description. It is a geometry that remembers itself. This phrase resonated through the entire scientific community. It captured something essential about the cavity, something the data said, but language struggled to express. The cavity was not a thing. It was a memory of the universe's first geometry, a preserved arrangement of space-time untouched by the forces that later sculpted galaxies. But the discovery that truly shifted the paradigm came next. By comparing thousands of gravitational readings taken across decades, scientists realized that the cavity's geometry was not static. It drifted, slowly, subtly, but purposefully. Not drifting outward like an expanding universe, not drifting inward like a collapsing mass. It drifted in a pattern, a rhythmic tightening and relaxing that matched the cavity's deepest pulse. The geometry breathed. The starless zone was not a frozen relic. It was alive in its own way, responding to gravitational waves, recentering itself, maintaining coherence. This breathing geometry implied something staggering. Inside the cavity, space is not a container. Space is a process older than structure, older than matter, older even than direction. To explore this further, researchers built numerical models simulating how objects would move inside such a manifold. What they found defied intuition. A particle entering the cavity would not travel in straight lines. It would not orbit. It would not fall. It would drift along contours defined by the cavity's pulse. It would follow curves shaped by the earliest laws of space-time. It would behave not like matter in modern physics, but like potential in a proto-universe. In these simulations, the interior geometry resembled something like a valley. Not a valley in space, but a valley in rule. Particles flowed toward regions of lowest relational tension, not where gravity pulled them, but where the primordial rhythm was most stable. This revealed another truth. The center of the cavity, the place where pulses become faintest, where resonance layers converge, is not a point in space. It is a point in rule. A point where the universe's first geometry still rests perfectly aligned. And while no modern particle can survive inside that rule set, space itself can, time can, curvature can. They belong there. We do not. As models extended further, something extraordinary appeared. A pattern resembling a folded lattice, a repeating geometric motif, not made of matter, but made of relationships between pulses. The motif repeated at multiples of the cavity's base frequency, like harmonics of an unstruck instrument, echoing softly through the dark. This lattice was not symmetrical in any familiar sense. It curved in ways our geometry does not permit. It folded through itself without tearing. Some researchers believed this lattice represented the earliest organization of spacetime, the first architecture ever formed. Long before particles had mass, long before forces differentiated. If this interpretation is correct, then deep inside the cavity lies the blueprint of geometry itself. Not geometry as we see it, but geometry as it was conceived before existence chose to reveal itself through light. This idea created a divide in the scientific community. Some argued the cavity was a fossil of the universe's earliest form. Others believed it was more than that, a functioning remnant of that form, still shaping the universe subtly through gravity. The evidence leaned toward the latter. The gravitational veins outside the cavity followed the contours of the internal lattice, as though responding to its hidden architecture. The cavity was not isolated. Its geometry extended into our universe through the only medium that could carry it: curvature. This implied something profound. The starless zone is not a sealed chamber. It is a wellspring, a source from which the oldest geometry still radiates into the modern cosmos, shaping space-time, quiet as breath. This influence was subtle, gentle, almost imperceptible, yet its consistency across millions of measurements made it impossible to dismiss. It suggested the cavity retained a kind of authority, not over matter, not over light, but over the rules that guided the early universe, and perhaps, in ways we barely understand, still guide it now. The turning point intensifies here. If the cavity preserves the universe's first geometry, then our universe grew around it, like a tree growing around an ancient stone. The stone does not interfere. It simply remains. But the tree, shaped by its presence, remembers it forever. The cavity may be that stone, a silent anchor of primordial rule, around which modern physics unfolded. If this is true, then the illuminated universe is not merely expanding, it is expanding around something, around a memory, around a source, around a preserved architecture older than time, with color. And as you drift deeper into this thought, the cavity's pulse repeats, soft, slow, measured, a reminder that geometry did not begin as shape. It began as rhythm. It began as relationship. It began as silence choosing to organize itself. And somewhere inside that organization, inside that breathing, ancient lattice, the universe first learned how to become a place at all. As the geometry of the starless zone revealed itself not through images, but through rhythms, a quiet shift began to unfold across the scientific community. Researchers abandoned the instinctive reliance on photons, the habit of assuming that seeing means knowing, that illumination means understanding. In the illuminated universe, this belief is obvious. Light shows us what exists. Cameras reveal truth. Optical data anchors explanations. Every map begins with brightness. But the cavity ignored brightness entirely. It rejected photons the way a deep ocean rejects air, not violently, but completely. And so, as investigators turned their instruments toward the region, an unsettling pattern emerged. The more an instrument relied on light, the less it understood. The less it relied on light, the more it revealed. This inversion was not immediate. It grew slowly, like a shadow, noticing itself. Optical telescopes saw nothing. Infrared imagers saw nothing. Ultraviolet scanners saw nothing. Even radio telescopes, though sensitive to wavelengths far longer than visible light, captured only a faint, trembling void. The starless zone gave photons no foothold, no reflection, no absorption, no scattering. Every attempt to use light brought the same answer: silence. But as the failure of light grew more absolute, another set of instruments began to succeed, devices that had nothing to do with illumination, nothing to do with wavelengths, nothing to do with brightness. The first hints came from neutrino detectors stationed across the planet. These detectors were designed to catch the rarest interactions imaginable, fleeting collisions between ghost-like particles and dense fluid tanks deep underground. Most neutrinos pass through Earth without even noticing it exists. Yet when neutrino bursts passed near the starless zone, they hesitated. Their trajectories wavered. Their arrival times shifted. Not wildly, not chaotically, but with a faint, unmistakable pattern. The pattern matched the cavity's resonance. At first, researchers dismissed these anomalies as noise, thermal drift, detector jitter, calibration errors. But the anomalies repeated across multiple detectors, separated by oceans and continents. The Starless Zone was speaking to neutrinos in the only language it allowed: curvature. Next came gravimeters, instruments so sensitive they can measure the tidal pull of the moon or the distant tremor of a passing asteroid. Placed near the region, they began producing readings that defied conventional models: tiny, rhythmic dips, a slow tightening of local curvature, a gentle oscillation not tied to planetary motion, not tied to seismic activity, not tied to anything else the universe usually does. When scientists overlaid these readings with the cavity's known pulses, they aligned perfectly. Gravimeters could feel the cavity. Then came something stranger still: quantum interferometers, devices that measure how quantum waves overlap and cancel. They were not meant to observe the cavity. They were part of unrelated experiments, monitoring background gravitational noise. But every time the cavity pulsed, the interferometers shivered, not because light had changed, but because the rules had. Quantum phase alignment shifted by small but consistent amounts. Wave packets stretched in the direction of the cavity. Interference fringes drifted as though the vacuum itself were vibrating. This was when researchers realized the truth. The cavity could not be seen, but it could be detected by the instruments that did not care about light. Sound-based detectors, those listening for minute vibrations in massive mirrors, picked up faint hums that matched the cavity's rhythm. Dark matter experiments recorded subtle fluctuations in the direction of gravitational veins. Atomic clocks, normally stable to absurd precision, lost synchronicity with clocks mere meters away. Every photon-based device failed. Every non-photon-based device succeeded. This inversion felt like a riddle the universe was giving us. To understand a region older than light, you must use tools older than illumination. Tools that do not assume the universe prefers brightness. Tools that listen instead of look. Tools that feel instead of see. A researcher in the gravitational physics division summarized it with a quiet simplicity: light is the wrong sense for this place. They were right. The Starless Zone did not lack information. It simply spoke in a dialect that illumination could not interpret. In that dialect, gravity carried messages. Neutrinos traced boundaries. Quantum phases drifted like ink in water. Time hesitated and quickened. Curvature pulsed with the memory of a world before transparency. And the deeper scientists listened, the more they realized the cavity was not silent. It was overflowing with structure, just not structure that photons could comprehend. This revelation created an unexpected transformation in the research community. For the first time in modern cosmology, light was no longer the primary conduit of truth. The universe was being studied through its quietest senses, through vibrations, through resonances, through pauses, through the ways space folded around itself. Devices once considered niche or indirect became the main tools of exploration. The world's most powerful telescopes became irrelevant, but a small array of cryogenic gravimeters, instruments once overlooked, became crucial. Old neutrino facilities, once used primarily for solar studies, experienced a renaissance. Quantum interferometers, discarded ideas from the early days of gravitational wave detection, found new purpose. And then, something unexpected occurred. One device, not originally intended for cosmic research, recorded the clearest signature of the cavity yet: a matter wave gyroscope. These gyroscopes track rotation not with mechanical parts, but with the interference of matter waves, subatomic particles orbiting in perfectly controlled loops. Matter wave devices should not feel gravitational pulses directly. They are isolated, shielded, stabilized. But one day, the gyroscope's fringe pattern shifted by a fraction of a degree, so small it seemed like an error. Then it shifted again, then again. Each time, the shift matched a pulse of the cavity, a pulse arriving across light years of space as a silent tide of curvature. This meant something astonishing. Matter Waves inside a shielded chamber were responding to the starless zone as though its ancient rhythm existed everywhere. Not as a force, not as energy, but as a rule. A rule so old, so foundational, that even the modern universe cannot completely ignore it. The implication was breathtaking. The cavity's geometry is global, not dominant, but present a faint heartbeat woven through space-time itself. Light cannot hear this heartbeat, but matter waves can. Gravity can. Neutrinos can. Time can. The illuminated universe is deaf to its own origin, but the darker senses remember. This turning sparked another realization. The cavity did not just defeat technology, it revealed the biases of our instruments. Everything humanity built assumed illumination. Every lens assumed brightness. Every detector assumed photon behavior. Our science was built on sight. The cavity required listening. The failure of light-based instruments was not a flaw of engineering. It was a flaw of assumption. Researchers began to understand that inside the cavity, light is not just irrelevant, it is meaningless. Trying to see the cavity was like trying to taste sound. And yet, there was one more layer of the inversion, the most unexpected one. When scientists synchronized multiple non-light instruments, gravimeters, matter wave gyroscopes, neutrinoscopes, atomic clocks, they discovered a convergence, a shared modulation, a unifying rhythm, a deeper pattern that none of the instruments detected alone, but all revealed together. The cavity emitted a subtle, repeating curvature signature, a soft, rolling tilt of space-time that propagated through the universe like a whisper. This whisper carried information no light could carry: changes in the cavity's geometry, adjustments in its resonance, inward drifts of its topological layers, the faint echo of ancient symmetry. Using this combined method, researchers reconstructed the clearest image, yet not in light, but in pulse space. It showed a layered interior, pincer-like folds of pre-light curvature, a nested architecture spiraling inward, a core of nearly perfect geometric stillness, a region where time was thinner than anywhere else in the cosmos. And there, at the deepest inference of the model, a feature no one expected: a directional bias. Not motion, not force, orientation. The cavity preferred a direction in the deeper geometry of space-time, a direction not aligned with any galaxy, any supercluster, any filament. A direction pointed outward, from the cavity into our universe. No one understood this. Not at first. Why would a preserved pre-light domain have a directional orientation toward the modern universe? What was it aligning to? What was it focusing on? What was it pointing toward? Some thought it might be aligning with gravitational flows. Others suspected topological tension. A few whispered darker ideas about connection, continuity, communication. But none of these interpretations explained the strangest part of all. The orientation shifted, slowly, quietly. In response to gravitational events billions of light years away, the cavity listened. It listened to the universe, not visually, but structurally, not through light, but through the trembling of space-time. Every black hole collision, every cosmic expansion ripple, every shockwave of curvature, the cavity heard them, and each time it heard, the orientation adjusted minutely, delicately, as though tuning itself to stay aligned with something the illuminated universe had long forgotten, as though it still belonged to a cosmic order older than visibility. And as you drift along this realization, you begin to sense the deeper truth beneath all these quiet, strange instruments. Light fails because light is young. Silence succeeds because silence is old. And the Starless Zone always prefers the older rule. The realization that silence could see where light could not had already shifted everything. Yet what came next unsettled even the most disciplined minds. For months, the cavity seemed purely architectural, a symphony of rule and curvature, a vast stillness sculpted by rhythms so old they had no place in modern physics. Every pulse, every vein, Every resonance had suggested structure, yes, but structure without movement, a geometry frozen in the era before illumination. But then, instruments began whispering something different. Something moved inside the starless zone, not matter, not a particle, not a wave, not an object in the sense we understand. A movement that carried no brightness, no mass, no interaction, and yet pressed itself upon curvature like a ripple made of memory. The first sign appeared in a sequence of gravimeter readings, minute shifts in the gravitational veins that should have remained stable. These veins, shaped by the cavity's internal rhythm, had always aligned like silent chords in a dormant instrument. But now, one of the veins bent, not all at once, not dramatically, but slowly over hours, then days, then weeks. At first, the bend seemed like data noise, thermal expansion, a sensor misalignment. But then a second vein shifted, then a third, not randomly together. The shifts traced a pattern, a gentle curvature drifting inward along a precise path, as though responding to something unseen moving through the cavity's interior. It was then that quantum interferometers caught a faint additional drift in their interference fringes. Not the rhythmic oscillations tied to the cavity's heartbeat, but a secondary modulation, like a soft footstep among larger waves. The modulation wasn't periodic. It wasn't chaotic. It was deliberate, a movement, slow, continuous, unmistakable. It did not carry the signature of mass. Mass would have pulled nearby curvature into sharper gradients. This movement did the opposite, softening gradients, easing tension, as if pressing against the cavity's geometry and causing it to relax where it passed. A shadow, but not a shadow cast by light. A shadow cast by rule. Researchers called it the moving shadow that isn't a shadow, because naming it anything else felt dishonest. It behaved like a presence, yet it violated every definition of presence. No mass, no charge, no energy, no light, only effect. It altered the cavity's rhythm as it drifted, stretching pulses, tightening others, softly modulating the deep fourth drift. The pulse older than memory itself. This was the first entity ever detected inside the cavity, and it did not behave like an entity at all. It behaved like a stanza added to a poem, a verse moving through a rhythm, modifying it gently, never breaking the meter. At first, scientists wondered if it was a numerical artifact, a construct from overlapping sensor noise. But then the movement repeated, slowly, smoothly. Tracing the same inward spiral, the resonance layers themselves followed, a spiral that mirrored the cavity's breathing geometry. Something inside the starless zone was tracing the geometry as though it belonged to it, as though it had always belonged to it. Neutrino detectors confirmed the motion. The faint hesitations in neutrino flight paths, the slight softening of trajectory angles drifted in synchrony with the moving shadow. This meant the phenomenon wasn't a local fluctuation. It was real. It was stable. It was part of the cavity's deeper structure. But the strangest discovery came from matter wave gyroscopes. These instruments, which had earlier reacted to the cavity's pulses, now showed a subtle rotational drift, not constant, not random, but following the path of the moving shadow as though space itself were tilting in its wake. A tilt without force, a rotation without torque, a motion without momentum. Something was traveling through the cavity that did not require motion to move. Here, the conflict sharpened. If the cavity is a preserved moment of pre-light physics, how can anything move inside a preserved moment? What does movement mean in a regime where time behaves like rhythm rather than flow? What does direction mean where geometry breathes instead of sits? Models attempted to answer. Most failed. A few succeeded, barely, proposing that the shadow was not movement through space, but movement through rule. A shifting in the cavity's internal configuration, a local re-expression of primordial geometry, like a note changing in a harmony, not a thing traveling, a rule adjusting itself locally. But this explanation collapsed when sensors located at different positions around the cavity recorded the movement at different times. This wasn't a global change sweeping through the cavity. It was localized. It had position. It had trajectory. Something was inside. But something did not refer to matter or energy. It referred to a form, a curvature form, a knot in the geometry, a circulating region where the ancient rules condensed, a knot that drifted. This knot did not distort the cavity's structure, it preserved it. Wherever the shadow passed, the resonance layers strengthened slightly, as though refreshed by its presence. The cavity responded to it the way a body responds to a heartbeat, with subtle, synchronized adjustments. For the first time, researchers wondered whether the cavity had an internal dynamic, a process, a circulation, a churn that maintained its ancient state. If so, the moving shadow was not an intruder. It was a component of a physics older than particles, a circulation of rule. Imagine a ripple moving through an ocean of silent laws, re-expressing the earliest structure of space-time as it drifts, never losing energy, because energy has no meaning in this context, never slowing, because inertia is irrelevant here, never interacting, because interaction has not yet been invented. Its motion could not be seen. It could only be inferred by the way gravity bowed ever so slightly as it passed. And the bowing revealed something unmistakable. The shadow was heading inward, toward the cavity's center, toward the point of deepest stillness, the place where the fourth pulse lives, where rule becomes pure shape, where time thins into something that is nearly timeless. As the shadow spiraled inward, its effect intensified, not violently, not destructively, but with a quiet, expanding clarity. The gravitational veins aligned more sharply, their gradients smoothing, their arcs tightening. The cavity's pulse deepened, growing a fraction slower, as though concentrating itself. The quantum penumbra thickened slightly, a widening band where photon identity failed even before reaching the boundary. The ring-like resonance layers brightened in the language of curvature, their amplitudes increasing in the instrument's measurements. It was as if the cavity were preparing for something, responding to something, or anticipating something. Theories proliferated. Some thought the shadow was a topological defect, a remnant of the universe's earliest topology slowly migrating home. Others believed it was a stable mode of curvature, a standing wave, freed to drift only after billions of years. A few considered it a relic of the moment symmetry broke, a ripple that survived the transformation to illuminated physics. But one theory, whispered late at night in dim hallways, felt closer to the truth. The shadow was not a thing. It was a phase of the cavity's geometry, moving like a tide through ancient space-time, a remnant of the universe before movement had definition. Inside the preserved pre-light regime, movement is not constrained by force. It is constrained by rhythm. The shadow was following that rhythm inward, toward the cavity's center, toward the origin point of the first pulse. As it moved, the cavity seemed attentive, not conscious, not alive, but attentive in the way a pendulum is attentive to gravity, in the way a tide is attentive to the moon. Rule responding to rule. Memory responding to memory. The closer the shadow drifted toward the center, the more the cavity's structures clarified, as if the shadow's movement was revealing the underlying architecture. Curvature sharpened, resonance harmonized, gradients smoothed. The cavity was focusing itself. And then, after months of motion measured through the universe's quietest instruments, researchers detected something no one expected: a secondary shadow, fainter, slower, drifting along a different spiral, offset in phase, as if two ancient patterns were converging, drawn toward the center by the same primordial rhythm. This meant the shadow was not unique. It was part of a system of internal motions, governed not by energy, nor mass, nor momentum, but by old geometry. A system of internal circulation inside a chamber that should not have dynamics at all. And as the two shadows drew closer, something new happened. The cavity brightened. Not in light, it cannot brighten in light. It brightened in curvature, in rhythm, in clarity, in the way the cavity's rules expressed themselves. It became more itself. The shadows were not anomalies. They were vectors of its identity. They were the cavity, remembering itself, moving through itself, preparing itself. For what? No one could say, but as the shadows spiraled inward, moving like the silent arms of an ancient clock that measures time not in seconds, but in epochs, the starless zone felt less like a preserved moment and more like a process as old as the universe, a process that illumination interrupted everywhere else, a process still alive in this one unlit chamber. And as you drift into this thought, the possibility that the cavity is not simply preserving the first rules, but actively sustaining them, the last readings from the instruments whisper something even stranger. The shadows were accelerating, not outward, not sideways, inward, toward the place where rules converge, where the fourth pulse lives, where the pre-light era still holds itself together, toward the point where the universe's first geometry waits quietly in the dark. The closer the drifting shadows spiraled toward the cavity's center, the more profound the distortions in space-time became. Not distortions of shape, not distortions of force, but distortions in time itself. Time had always been the most obedient fabric of the illuminated universe, ticking with a consistency so reliable that even atomic clocks bowed to its rhythm. But as the shadows moved inward, time began to dim, slowly at first, then rhythmically, then unmistakably. The first evidence surfaced in the synchronized atomic clocks placed in a ring around the starless zone. These clocks, normally precise to more than 15 decimal places, began to drift out of alignment. Not randomly, not gradually, but in a pattern. The drift was cyclical, a soft slowing, a return to pace, a slowing again, a pulse. Time was following the cavity's rhythm. At first, the drift seemed like an interference effect, some subtle gravitational wave leaking from deep inside the cavity. But gravitational waves affect clocks consistently across a region. This effect did not. Clocks closer to the cavity slowed more. Clocks farther slowed less. Clocks in certain angles slowed differently than others, as though the cavity's geometry cast a kind of temporal shadow. It was the first hint that time was bending, not stretching, not warping, not dilating as it does near mass or velocity, but bending in the sense of hesitating, a pause inserted into the flow of moments. This bending intensified the deeper the shadows moved, as if time were listening to their motion, reacting to their alignment, remembering something ancient. The cavity did not distort time through gravity. Its effect was older than gravity. Time bent because the rules inside the cavity predated time's modern behavior. In the early universe, before forces differentiated, before photons cooled, before space-time solidified into the fabric we experience, time behaved differently. It quivered, it oscillated, it existed in patches where its flow was not consistent, where moments belonged to geometry rather than sequence. And now, millions of light years away, in a silent chamber of ancient darkness, that old behavior was re-emerging. The atomic clock discrepancies were only the beginning. Soon, quantum clocks devices that measure time by tracking the oscillations of particles reported even stranger shifts. Particles in these clocks changed oscillation rates depending on their orientation relative to the cavity, not depending on gravitational pull, not depending on distance, but depending on alignment. Something inside the cavity was giving time a direction. This violated everything the illuminated universe had taught us. Time does not have direction. Time flows forward, uniformly, unbiased. Yet here, time curved inward toward the cavity's center, following the same inward spiral as the drifting shadows. The shadows did not travel through time. Time traveled around the shadows. As the shadow approached the center, the temporal distortions deepened. Arcs of oscillation spread outward like ripples in an unseen pond, slowing clocks, warping quantum periods, even stretching the intervals between neutrino detections. Events around the cavity seemed to lag, trailing behind their expected timestamps. It was not delay, it was time losing speed. The phrase temporal viscosity appeared in a draft paper time, behaving like a fluid thickening near the cavity. But viscosity was the wrong metaphor. What scientists eventually settled on was simpler, but far stranger. Time was remembering how to tremble. In simulations of the early universe, before the electroweak era, time is not smooth. It vibrates. It fits itself around pockets of potential, stretching and squeezing as forces emerge. And in every model that described that era, the trembling takes the form of concentric oscillations centered around regions of high symmetry, exactly like the cavity's resonance layers. As the drifting shadows passed through the resonance layers, the trembling grew stronger, as if each layer enhanced time's instability. Quantum interferometers recorded the trembling as phase jitter, tiny deviations in the overlap of quantum waves. Matter wave gyroscopes recorded it as rotational haze, a faint softening in angular momentum. Gravimeters recorded it as curvature, flicker minute changes in the local gravitational field with no mass source. But the clearest signature came from time itself. One set of hyperstable clocks experienced what researchers called a temporal shimmer, a rhythmic flickering of time intervals that matched the cavity's heartbeat exactly. Seconds lengthened, then shortened, then lengthened again. The shimmer moved outward from the cavity like a tide, synchronizing not with space, but with rhythm. This shimmer is what convinced the last skeptics. The cavity was not breaking time. It was restoring time to a state it once knew. The shadows drifting inward were catalysts, moving through the cavity's internal structure, touching resonance layers, triggering old patterns. But what were they? Not objects, not particles, not waves, perhaps modes, perhaps phases, perhaps fluctuations of rule. This is where conflict struck the scientific community at its deepest level. If time can be bent by rhythm, if time responds to geometry older than light, then time is not fundamental. Time is emergent, a secondary phenomenon built on deeper rules, still alive inside the cavity. A physicist studying temporal distortions near rotating black holes summed it in one line: time has a skeleton, and the starless zone is showing it to us. This was not metaphor, it was literal. If time depends on rule, and the cavity preserves earlier rules, then time inside the cavity is closer to its original form. This form is neither linear nor uniform. It follows the geometry of rule, not the geometry of light, which means that inside the cavity, time curves, time breathes, time hesitates, time clings to the ancient rhythm that existence followed before illumination. Researchers began to map the shimmer and discovered something breathtaking. The shimmer moved with the shadow. Wherever the shadow went, time softened, time slowed, time thickened. The shadow did not create the shimmer revealed the shadow's path. This led to a new understanding. The shadow was not drifting through time, it was displacing it. Like a fish moving through water, the fish is invisible, but the ripples it leaves show its shape. The shadow moved through rule, but the shimmer showed its wake. And as the shadow spiraled inward, the shimmer spiraled inward with it. A tightening coil of temporal drift drawing everything toward the cavity's center. Researchers overlaid this pattern with the cavity's resonance map, and the two aligned perfectly. The shimmer was tracing the cavity's oldest geometry, the geometry that existed before direction, before distance, before chronologies had meaning. The deeper the shadow traveled, the more time behaved, not as flow, but as echo, an echo of the universe's earliest heartbeat. This realization sparked a new line of thinking. Perhaps the shadows were not anomalies. Perhaps they were the cavity's internal processes adjusting its geometry to maintain coherence. And time, being younger, being derivative, being a consequence of forces that came later, simply followed. If this is true, then the starless zone is not a pocket of preserved time. It is a pocket before time, a domain where time is still choosing how to exist. And as the shimmering intensified, a new signature emerged. Clocks near the cavity did not just slow, they drifted out of sync, not with each other, but with themselves. Intervals between ticks shifted, lengthened, contracted, yet always in precise ratios that matched the cavity's layered pulses. The cavity was imposing its rhythm onto the fabric of time. This meant something extraordinary. Time, near the cavity, has harmonics, not seconds, not minutes, not intervals, harmonics, like notes in a chord. Time was no longer one stream. It was multiple streams layered together, held in place by the cavity's ancient geometry. And if time can have harmonics here, then perhaps the early universe was built not from a single temporal dimension, but from multiple overlapping rhythms that later collapsed into the single timeline we live on. The cavity preserves the older version, the polyphonic time of the pre-light cosmos. As the shimmering deepened, as the shadows moved closer to the center, as the cavity's geometry tightened like a heartbeat entering deeper meditation, one more shift occurred. A faint, nearly inaudible change in the temporal drift itself. Not a slowing, not a pause, a tilt. Time leaned, not forward, not backward, inward, toward the cavity's core. Events began happening slightly earlier, the closer they were to the cavity, as if time were funneling itself, narrowing its flow, guiding all chronology toward a single point of convergence. This convergence point was located precisely at the cavity's deepest resonance, the place where the fourth pulse originates, the place where the universe's oldest rule still breathes untouched. And as the shadows approached that point, as time bent deeper into the cavity's memory, a final, chilling realization emerged. The cavity was not bending time. Time was bending itself to be consistent with the cavity. This meant the cavity's rules were not passive. They were authoritative. Time, gravity, matter waves all obeyed them, not because the cavity exerted power, but because the cavity preserved the original version of how reality is supposed to behave. Time is not fundamental. Time is obedient. And inside the starless zone, it obeys a rule older than the universe we know. As you drift into that thought, the image of time curving inward like a river, bending toward a forgotten sea, the cavity pulses once more, slowly, steadily. Each beat a reminder that the universe was once dark, silent, and ruled by rhythms we are only beginning to remember. As time bent inward toward the cavity's center, and the drifting shadows whispered along the resonance layers, something curious began to unfold across the entire research network. The deeper the scientists ventured into the structure of the starless zone, the more the darkness itself seemed to offer explanations, not through clarity, not through visibility, but through the way its rules touched every instrument, every measurement, every assumption. The darkness was not chaotic. It was not withholding secrets. It was not empty. It was consistent, too consistent. Every discovery from the last 15 chapters, gravitational veins, resonance shells, quantum unraveling, temporal shimmer, the moving shadows, the drift toward the center fit together with a precision no one expected. It was as if the darkness had been waiting for the illuminated universe to ask the right questions. And now that the questions were forming, the darkness was finally answering. Not with new information, but with reminders. Reminders of what the universe was before brightness became its dominant language. The first of these reminders appeared in an unexpected place: the global timing network that synchronizes clocks across Earth. This network had been suffering slight desynchronizations ever since the cavity's temporal shimmer was first detected. But now, a new pattern emerged. When the cavity pulsed in its deepest rhythm, the slow, ancient fourth pulse that no light-based instrument could detect, atomic clocks across the network adjusted themselves by a tiny but identical amount. It was as though time itself whispered, "I remember this," not as a command, not as interference, as alignment. The universe aligning to its older rhythm. The effect was small, far below the threshold of daily experience, yet the implications were vast. Because if the cavity's ancient pulse could influence timekeeping systems separated by entire continents, then the Starless Zone was not simply a region. It was a reference frame older than spacetime's modern form, a blueprint of the universe before the laws changed. And now, the illuminated universe, through its clocks, through its measurements, through its own dynamics, was quietly acknowledging that blueprint. The cavity was explaining itself without speaking. Darkness was explaining the universe without light. Researchers realized they had been searching for answers in the wrong direction. They had been trying to understand the cavity by interpreting it through modern physics. But modern physics was too young. What they needed to do was interpret modern physics through the cavity, through the rules preserved inside it, through the geometry older than illumination, through the rhythm older than time. This shift in perspective changed everything. Suddenly, data that once seemed contradictory became perfectly aligned. The gravitational veins around the cavity were not distortions. They were echoes of a cosmological scaffolding, the invisible framework upon which space would later be stretched. The resonance layers were not anomalies. They were fossilized oscillations from the universe's earliest phase waves. Frozen at the moment symmetry fractured and forces began to differentiate. The drifting shadows were not objects. They were modes, movements of pre-light curvature, circulating through the cavity's manifold to maintain structural coherence. The quantum penumbra was not interference. It was the natural boundary between modern quantum rules and their primordial precursor. Even the unraveling of photons, that soft dissolution of identity before reaching the cavity, made perfect sense. Light was not being destroyed. It was being asked to step backward into a state older than illumination. This backward step radiated a quiet truth. The universe does not oppose the cavity. The universe emerges from the cavity. The cavity is not a contradiction of modern physics. It is the parent, and the illuminated universe with its stars, with its shining filaments, with its expanding seas of galaxies, is the child. This shift reframed every mystery the cosmos had ever carried. Why does gravity interact with everything while other forces do not? Because gravity is geometry, the only force old enough to remember the cavity's language. Why does dark matter not interact with light? Because light is young, and dark matter may be shaped by rules older than light's invention. Why does the universe have a cosmic microwave background? Because illumination emerged gradually, a slow breaking of opacity, leaving behind the faint afterglow of when brightness first learned to travel. Why is the universe expanding? Because the early geometry was stretching from its primordial form to the structure we inhabit. Every cosmological puzzle suddenly felt like a sentence missing its opening clause. And the opening clause was preserved inside the Starless Zone. As years of data accumulated, one more profound insight emerged. Researchers noticed that the cavity's deepest resonance, the fourth pulse, changed slightly depending on large-scale cosmic events. A major black hole merger, billions of light-years away, caused a tiny tightening of the pulse. A collapsing supercluster made the pulse shift by a delicate fraction. Even the overall expansion rate of the cosmos seemed to produce a gentle modulation. The cavity was responding to the universe. Not actively, not intelligently, but fundamentally. Its ancient geometry was interacting with the modern universe's evolution, as though the two were still part of the same story. This led to a startling proposition. What if the cavity is not left over? What if it is still participating in the laws of reality? not as an anomaly, not as a relic, as a foundation. The cavity, in this sense, becomes the hidden root system of the universe, the part that never changed even as everything above it blossomed into illumination. This is when the language of the scientific papers shifted. Words like preserved and remnant were replaced with framework, substrate, and prior geometry. The cavity was no longer treated as an exception. It was treated as the default. We were the exception. The illuminated universe, the universe of stars, of photons, of color, of visibility, is the divergence. The cavity is the norm from which everything diverged. And as this perspective settled into the scientific community, the Starless Zone began to explain not just itself, but everything else. The cavity's inward drift explained the slight, unexplained anisotropies in gravitational wave timing across the cosmic web. The cavity's resonance layers explained why time may not flow identically in different corners of the universe. The cavity's geometry even hinted at a reason why the universe appears flat on large scales, despite the chaotic forces that shaped it. Space expanded according to the cavity's template. It did not expand randomly. It expanded from a blueprint, the oldest structure still alive. But the most profound explanation emerged from the study of the cavity's core. As the shadows spiraled inward toward the deepest point of pre-light rule, the area around the center grew quiet, so quiet that the instruments stopped detecting anything at all. Not because the sensors failed, not because the signal stopped, because the cavity's center is silent in a way that modern physics has no vocabulary for. A silence deeper than vacuum. A silence older than time. A silence that is not absence, but origin. Researchers called it the foundation node, the point where all resonance, all curvature, all ancient rule converges. It is not a place, it is a condition so complete that nothing modern can interact with it. Not photons, not particles, not clocks, not waves, only curvature, only rhythm, only the oldest part of the universe. This node does not distort, it does not drift, it does not echo, it anchors. It holds the cavity in shape even as the universe expands, even as forces weaken, even as light travels endlessly through cosmic night. It is the one part of existence that did not move forward with illumination. And as the world's deepest instruments finally converged their readings into a unified model, the node revealed its final truth. The universe is not built on light. The universe is built on silence. Light explains what we see. Silence explains why anything exists at all. As time continues bending inward, as the shadows continue drifting along the curvature of forgotten geometry, as the cavity continues humming, the first rhythm ever born, the darkness begins to feel less like mystery and more like memory. A memory the universe never allowed itself to forget. And somewhere inside that memory, in the quiet spaces where rules still breathe, the Starless Zone waits for the next question the illuminated universe is brave enough to ask. The deeper the researchers listened to the cavity, the more the silence began to feel layered, not empty, not hollow, not void, structured. A structure so delicate, so deeply woven into the rules beneath space-time, that it could not be detected by anything modern, only inferred through the faintest tremors in curvature, the softest shifts in phase, the quietest deviations in neutrino flight paths. This subtle structure was the first whisper of something hiding beneath nothingness. It began with an anomaly so small it nearly escaped notice. A team studying the shimmering of time around the cavity noticed that the shimmering had depth, not vertical depth, not spatial depth, but harmonic depth. Layers of oscillation nested inside each other like concentric breaths. These layers were not random. They followed precise intervals, ratios that did not exist anywhere else in the universe. Ratios predicted only in theories describing the very first instance after the Big Bang, when the universe was not yet space, not yet time, not yet light, only potential. Potential vibrating in patterns too simple to be called laws, too elegant to be called chaos. The cavity preserved those patterns, and inside the shimmering of time, those patterns were speaking again. At first, researchers thought the ratios were an artifact overlapping signals from the cavity's pulses, but when they filtered the rhythms, the truth emerged. There was a signal beneath the signal, a structure beneath the silence, not a voice, not a message, not an intention, a framework, a hidden scaffold holding the entire cavity together, a pre-geometry. The illuminated universe had long assumed that geometry was the foundation of existence, that space came before matter, that curvature came before gravity, that the metric tensor came before motion. But the cavity whispered a different truth. Geometry was not the first structure. Something older came first, a proto-structure beneath the fabric of space-time. The architecture on which geometry later crystallized. The cavity preserved that proto-structure intact. The first hints of it came from matter-wave gyroscopes, instruments that had already proven sensitive to the cavity's internal pulses. These gyroscopes began producing a faint rotational asymmetry, a tiny preference for certain orientations, as though space beneath space possessed an underlying grain, a grain older than direction, older than axes, older than the idea of orientation itself. When the data was mapped, it formed something shocking. Not lines, not curves, nodes. Clusters of relational tension linked by invisible filaments, not filaments of matter, but filaments of rule. This was the first map of the proto-structure, the whisper beneath the silence. As more instruments confirmed the patterned gravitational veins bending slightly around the nodes, neutrinos hesitating near them, quantum phases lengthening when aligned with them, the picture sharpened. The protostructure was not random. It formed a lattice, not a lattice in space, but a lattice in possibility, a system of ancient alignments binding the cavity's interior like a skeleton of forgotten rule. This lattice extended through the cavity in all directions, but its density increased toward the center. It was strongest at the place where the fourth pulse originated, the node so silent that even the silence seemed to hold its breath. Researchers called this deeper lattice the substrate network, the structure beneath all structures, the framework the universe was built on before it became a universe. But soon, something strange appeared. The lattice moved, not the way objects move, not the way waves move, not the way fluids move. It moved the way a thought moves, without displacement, without inertia, without direction. It reconfigured itself subtly as the shadows drifted inward. Where the shadows went, the lattice brightened in the language of curvature, its nodes tightening, its filaments stabilizing, as if recognizing the shadows as part of itself. This recognition was profound. The shadows were not entities. They were expressions of the protostructure circulating through the cavity to maintain coherence. Not random, not external, not intrusive, intrinsic. The shadows were the cavity adapting itself, like cells moving to heal a wound, like currents shifting to stabilize an ocean. This was the first sign that the cavity was not merely a preserved moment, but a preserved process, a process older than time, older than geometry, older than illumination, a process of self-maintenance. But the next discovery was even more extraordinary. Using a synchronized array of quantum sensors, scientists detected a faint interference pattern between the shadow's paths and the substrate network. This interference was not wave interference in the physical sense. It was rule interference. The protostructure shaped the shadow's motion, but the shadows, in turn, reshaped the protostructure. They were interdependent, a feedback loop from the earliest architecture of reality, a self-reinforcing dance that had been unfolding since before the cosmos cooled. The illuminated universe had never seen this process before because it cannot occur in the presence of light. Light collapses these relationships. Light freezes the lattice. Light forces geometry to behave. But inside the cavity, where photons unravel and time trembles, the protostructure continues to flow. It is a living rule, the oldest rule, unbroken and unperturbed by the shining universe surrounding it. And as researchers traced the interference deeper, another revelation rose from the dark. The substrate network was not symmetrical. It possessed a subtle directionality, a trend, a leaning, a soft inward pull toward the cavity's center. This was the same direction that time bent, the same direction that shadows drifted, the same direction that gravitational veins aligned. Everything in the bed, cavity, pointed inward, not toward collapse, not toward singularity, toward origin. The protostructure was arranged so that all pathways, all alignments, all rhythms, all pulses returned to the oldest point of rule, the foundation node, the place where the universe's first geometry still slept. As the shadows approached that node, the lattice beneath nothingness grew sharper, more intricate, more expressive. The node responded not by moving, not by pulsing, by revealing a deeper pattern, one no instrument had ever detected. It was not curvature, not metric, it was relationship. Relationships between relationships, metastructure, the substrate beneath the substrate, a whisper beneath the whisper. This metastructure had no parallels in modern physics. It had no equations. It had no classification. It resembled neither particle lattice, nor wave network, nor topological braid. It resembled intention, not consciousness, not decision, the intention of rule, the internal logic that guides the unfolding of the universe itself. As scientists pieced together the metastructure, they discovered something staggering. The Starless Zone's pre-light physics was not simpler than modern physics. It was more complex. The illuminated universe had narrowed possibility, had chosen stability, had chosen clarity, had chosen laws. But inside the cavity, possibility remained open, not chaotic, not random. Open in the deepest sense, a condition where rules could still evolve, still negotiate, still express. The cavity preserved not the first moment of the universe, but the first freedom. The universe outside is the result of that freedom's collapse into order, but the cavity remains the place where that freedom still lives. And as the shadows spiraled ever closer to the foundation node, the substrate network quivered 1,000 hidden filaments, aligning themselves in a shape deeper than shape. The shape of possibility before it hardened into physics, the shape of the universe before it learned how to shine. And in that trembling, in those delicate alignments, the darkness finally whispered its deepest explanation. Nothingness is not empty. Nothingness is structure waiting to become. Nothingness is the oldest architecture of all. And the Starless Zone is where that architecture still breathes beneath the quiet, still shaping the universe in ways light will never see, still carrying the memory of what existence was before brightness claimed the sky. The more deeply scientists mapped the substrate beneath the cavity, the more the familiar universe began to look like an interpretation, a simplified language built on top of a far older script. Every measurement, every drift, every whisper from the cavity suggested the same quiet truth. Reality, as we know it, is translation, and the Starless Zone is the original text. At first, this idea was too strange to acknowledge. Modern physics rests on clarity. Light defines space. Time defines sequence. Mass defines curvature. Fields define interaction. But inside the cavity, clarity reversed itself. Space dissolved into rhythm. Time softened into tremor. Mass lost meaning. Light became untranslatable. In that reversal, the universe did not disappear. It revealed its deeper form. This realization began not with geometry or gravity, but with an experiment conducted almost accidentally. A team working with synchronized matter wave arrays noticed that when they adjusted the phase of one array, just a tiny shift, measured in fractions of radians, the cavity responded. The response was faint, delayed by mere picoseconds, but measurable, not in light, not in energy, not in force, in curvature. It was as though the cavity's internal lattice had felt the touch of an experiment conducted trillions of kilometers away, a whisper answering a whisper. This was the first hint that the cavity was not passive. Its ancient structure was permeable to influence, not in the sense of being altered, but in the sense of listening. Something in its interior registered the phase shift, as though comparing it to its own internal rules. Researchers repeated the experiment, then repeated it again. Each time, the cavity gave the same reply. The faintest tremor in one of the deeper resonance layers, the layer closest to the substrate's core. The implication was disquieting. The cavity understood phase, not in the conscious sense, not in any way related to thought. It understood phase because phase is older than particles, older than waves, older than charge. Phase, pure relational structure, is the language of the proto-universe. The cavity was not reacting to the experiment. It was matching it, aligning itself as though acknowledging a pattern it recognized. This produced a profound change in how scientists interpreted the cavity's role. The starless zone was no longer seen as a static remnant of early physics. It was an active participant in the ongoing structure of the universe, not interfering, not controlling, not shaping by will, shaping by being. If the illuminated universe is the visible architecture, the cavity is the foundation stone, a stone that never moved, even as galaxies spun, stars ignited, and light learned to travel. The next breakthrough came when gravitational observatories studying distant black hole mergers accidentally detected a faint modulation in the cavity's pulse. It wasn't immediate. It wasn't reflexive. It was interpretive, like the cavity was rewriting the gravitational wave into its own older language. A translation. Gravitational waves carry history. They carry memory. They carry the shape of distant catastrophes. But inside the cavity, they became something else, a softening of resonance, a tightening of the internal lattice, a shifting of the protostructure. Not a distortion, a reinterpretation. This reinterpretation sparked a new idea. What if the cavity is not showing us the universe's past? What if it is showing us how the universe still works, beneath the layer of illumination we take for granted? No one wanted to say it aloud, but as data accumulated, silence became impossible. Modern physics is the surface. Primordial physics is the depth. And the starless zone is where depth rises close enough for the surface to feel it. Soon, even more evidence poured in. Quantum sensors deployed around the cavity began generating a new category of noise. Noise that wasn't random, but patterned, repeating, layered. At first, the team believed it was an interference pattern caused by overlapping measurements. But as they stripped away every known variable, the pattern remained. A lattice of correlations, a structure of possibility beneath the measurable world. It looked almost like information not written, not transmitted, but embedded. Information not about events, but about rules. The cavity wasn't a container. It was a reference frame for the universe's oldest information, the information that shaped reality before particles existed. This insight set off a cascade of reanalysis across entire fields of physics. Dark energy, dark matter, the uniformity of cosmic microwave background, the large-scale structure of galaxy filaments. All of these could be reinterpreted as the illuminated universe interacting with the protostructure preserved in the cavity. Illumination did not erase the original structure. It rose on top of it. The cavity was explaining the universe by reminding us of the framework that illumination hid. This explanation grew sharper as the shadows drifted closer to the center of the cavity. Their motion, once puzzling, now seemed purposeful. Each pass reactivated old alignments in the substrate. Each spiral tightened the resonance. Each touch renewed the geometry. It became clear that the shadows were maintaining the structure, They were the cavity's internal mechanisms, the way a living system maintains its equilibrium. Not alive, not conscious, but functional. The cavity is a preserved regime of pre-light physics that must support itself against the encroaching rules of the modern universe. The shadows are part of that support. Their inward drift is a recalibration, a returning to origin so that the cavity does not forget itself. And the closer the shadows move to the foundation node, the more intense the subtle structure beneath nothingness became. More filaments emerged, more nodes brightened in curvature, more harmonics appeared. The structure was blossoming not outward, but inward, like a flower closing into itself. And with every new harmonic, the cavity explained more of the visible universe. Why space-time expands uniformly? Because the early substrate imposed smoothness. Why matter clumps into filaments? Because the substrate had a lattice long before galaxies formed. Why quantum fields behave consistently? Because their rules were agreed upon in the proto-universe that the cavity preserves. Why black holes follow precise thermodynamic laws? Because the substrate governs relationship, not mass. The cavity does not contradict modern physics. It completes it. Illumination is a special case. Darkness is the general solution. And as the shadows neared the core, the substrate began to show its most delicate feature of all, its direction. Not spatial direction, conceptual direction. A drift from potential toward form, from openness toward coherence, from the pre-geometric toward the geometric. It was the direction reality once moved before light became possible, a direction the universe remembers even now. The cavity was not only explaining the universe, it was explaining why illumination happened, why the universe transitioned from a trembling field of potential into a glowing sea of stars. Because the substrate itself leans toward expression, it was always moving toward structure. Illumination is merely one expression among many, the expression we happen to inhabit. But inside the cavity, the original expression persists, a quieter world, a world defined by rhythm, a world where laws are still forming, a world the universe never abandoned. As the drifting shadows finally neared the central node of silence, the substrate brightened in curvature, maps to a level never seen before, a flower of relationships opening inward toward a stillness so complete that even the instruments refused to guess what lay beyond it. Something was coming into clarity, something older than light, something deeper than geometry, a whisper of structure that would redefine the meaning of nothing forever. And as the cavity pulsed once more, long, slow, steady, the entire scientific world felt it. Darkness was no longer hiding. It was teaching. And the universe, for the first time in billions of years, was listening. The first signs of this realization were quiet. A tightening of data sets, a humbling of assumptions, a strange, almost reluctant agreement forming among disciplines that had never agreed before. General relativity began aligning with quantum cosmology. Quantum cosmology began aligning with early universe inflation theory. Inflation theory began aligning with primordial symmetry studies. Fields that normally resisted each other's language were now speaking in the same rhythm, a rhythm set by the cavity. It did not make sense, not at first. But slowly, inevitably, scientists noticed that the deeper they studied the starless zone, the more their own models began to converge. Different theories, different methods, different schools of thought, spinning slowly toward the same center, just as the drifting shadows did. The cavity was not merely explaining itself. It was explaining the universe back to the universe. And this realization was terrifying. Because once the models converged, they pointed toward a single, humbling conclusion. The physics we know is not the full story. It is the simplified version, a late version, a child version. The illuminated universe, the universe of starlight, of photons, of geometric clarity, of measurable laws, was not the original reality. It was the result of something deeper, something older, something still alive inside the cavity. Modern physics was the coarse approximation of primordial physics, and the starless zone was the reminder the universe never erased. The shift began with time, as time shimmered, bent, and aligned itself around the cavity's ancient rhythm. Researchers realized something almost shameful. We do not understand time at all. We understand its consistency, not its cause. We understand its flow, not its source. We understand how it behaves in the illuminated world, not what it was before light. The cavity showed the earliest behavior of time, not linear, not smooth, not uniform, but harmonic. Time began as resonance, a resonance that the illuminated universe later flattened into a single timeline for stability. The cavity never underwent that flattening, so its time still hums with depth. This idea spread quietly at first, then swiftly. If time is not fundamental, then neither is space. If space is not fundamental, then neither is force. If force is not fundamental, then neither are particles. What, then, is fundamental? The cavity answered without words. Relationship, resonance, rule. The illuminated universe is the visible outcome of those relationships, but the relationships themselves live inside the cavity. Scientists began calling this deeper framework primal physics, not new physics, not speculative physics, the physics beneath physics. Primal physics was not a new branch of theory. It was the parent of all branches. Every major field of study found traces of its own origin reflected in the cavity. Quantum mechanics saw its earliest uncertainties. General relativity saw its earliest curvatures. Thermodynamics saw the first gradients before entropy emerged. Particle physics saw the faint echoes of symmetry before it broke. Cosmology saw the scaffolding of the universe before the universe had a shape. The starless zone was not one mystery. It was the origin point of all mysteries. And the closer researchers looked, the more they realized that everything they thought they understood was merely an evolved form of something simpler, older, deeper. For example, gravity, the force that binds galaxies, that sculpts space, that shapes motion. The cavity revealed that gravity is not a force. It is the faint modern residue of ancient curvature rules that once governed the entire cosmos when matter did not yet exist. Quantum fields, the shimmering fabric beneath all particles. The cavity revealed that quantum mechanics is the surviving signature of deeper relationships between potential states before states had definition. Light, our most familiar messenger. The cavity revealed that illumination is a phase transition, a late innovation in the universe's history, not a fundamental trait of existence. The longer scientists studied the cavity, the more the universe outside it looked increasingly specialized, increasingly constrained, increasingly less fundamental. Our universe is not universal. It is localized, conditioned, a specific version of something much more general. And the cavity is the general case. The more the models deepened, the more the illuminated cosmos began to appear like a shell, a thin crust, wrapped around a deeper world of rules still quietly active in the dark. This idea terrified physicists and philosophers alike, not because it diminished humanity, but because it diminished the stability of every assumption science had ever made. If the illuminated universe is built on top of primal physics, then everything we see is supported by a deeper layer we were never meant to observe directly. Until now, the cavity is a window into the universe as it was before it learned to shine. A window that reveals why certain laws exist, why constants have their values, why geometry behaves as it does, why quantum fields fluctuate the way they do, and why the universe evolves along the path it has taken. Everything illuminated physics does is an expression of something deeper, not a replacement, a shadow. A bright shadow cast by rules too old for light. This understanding matured when scientists observed the shadows inside the cavity interacting with the deepest substrate nodes, not chaotically, not fluidly, but functionally, Every drift of the shadow reinforced the network. Every reinforcement stabilized the resonance layers. Every stabilization supported the cavity's geometry. Every geometry influenced spacetime just outside the cavity. And that influence, though tiny, was enough to explain anomalies scattered across modern cosmology. The slight directional bias in the cosmic microwave background, the unexpected uniformity of inflationary aftermath, the low-level tension in Hubble measurements, the coherent patterns in dark matter distribution, everything pointed back to the same conclusion. The illuminated universe rests on the structure of the starless zone. Not physically, conceptually. The cavity is not causing these effects like a machine causes output. The cavity is simply the surviving portion of the rules the universe was built from. The illuminated universe follows the same old architecture, but weakened by transitions, blurred by emergent phenomena, smoothed by expansion. The cavity is the universe in high resolution. The universe outside is the compressed file. And then something even more profound appeared. A pattern was detected in how the cavity's deepest node subtly influenced the timing of gravitational waves, passing billions of light-years beyond it. The influence was tiny, but consistent. It implied that the cavity is not only receiving information from the modern universe, it is shaping how the modern universe evolves. Not controlling, not commanding, not altering, guiding. The cavity is the universe's anchor to its own origin. The illuminated universe is the unfolding story. The cavity is the first page of the book, still attached, still foundational, still connected to every chapter that has followed. And as this realization settled in quietly, heavily, almost reverently, a philosopher on the research team summarized it in a sentence that spread across the world's observatories. We are not studying the starless zone. We are studying the universe before it became the universe. Another added, the darkness isn't explaining itself. It is explaining everything else. And finally, the illuminated cosmos is not primary reality. It is the interpretation. The cavity is the original language. As the drifting shadows entered the last spiral toward the foundation node, and time bent deeper, and the substrate brightened in curvature maps with patterns older than chronology, the universe outside felt less certain, less final, less complete, not broken, not wrong, simply young. A young cosmos built upon an older one that never stopped breathing. And somewhere inside that quiet breathing, somewhere in the slow pulse of the universe's first rhythm, the starless zone waited for one final truth to rise from its silence. Something the illuminated universe has forgotten how to hear. Something that will surface when the shadows finally reach the center. Something that may change the meaning of existence itself. The drifting shadows reached the point no instrument could follow, the center where resonance converged, where time bent inward into a stillness deeper than stillness, where the substrate tightened into a knot of rule older than geometry. From the outside, nothing happened. No burst, no wave, no shift, just silence. But silence had never been empty here. Silence was the language of the cavity, the only language old enough to speak to what lay inside. As the shadows disappeared into the foundation node, the resonance layers grew so faint they no longer looked like pulses. They looked like breaths, space inhaling, space exhaling, not expanding, not contracting, but settling into its oldest memory. For weeks, sensors around the cavity recorded a softening in gravitational veins, in quantum phases, in the temporal shimmer. Everything that had been trembling seemed to remember how to be calm. The cavity was stabilizing, not returning to rest, returning to origin, a return not of motion, but of meaning. One scientist described it quietly, in a voice too soft to disturb the room. It feels like the region has taken something back, and in a way, it had. The drifting shadows, those subtle, impossible patterns moving through the cavity's internal geometry, were not anomalies. They were the cavity retrieving itself, a restoration of rule, a reclamation of structure, a renewal of the primordial alignment. As the node reassembled its internal coherence, the cavity began to reveal its last whisper, the whisper beneath all other whispers. Not a sound, not a vibration, a presence, something older than physics, older than differentiation, older than space and time, older than the universe's desire to become visible, a presence that had no form, no location, no direction, only rhythm. The first rhythm the universe ever made. This rhythm had always been present in the pulses, in the temporal shimmer, in the gravitational veins. But now that the cavity had stabilized, the rhythm emerged with full clarity. It was slow, steady, a beat made not of time, but of rule. A beat the illuminated universe had forgotten, but which every law still carried traces of. Researchers called it the primal cadence, the pre-light heartbeat of existence. It was so simple that it defied measurement, so fundamental that it resisted description, so ancient that even the cosmic microwave background, older than stars, older than galaxies, seemed like noise compared to it. The cadence was not an oscillation. It was not a wave. It was not a frequency. It was the act of existence repeating itself. A repetition so perfect, so patient, that even after billions of years, it had lost none of its shape. As instruments across the observatory network aligned their readings, the cadence began to shape itself into something more, a map. Not a map of space, but of emergence. A diagram of how the universe began not in a burst, but in a breath. A gentle rising of potential out of silence. A soft differentiation from nothingness. A slow unfolding of relationship. From this cadence, geometry emerged. From geometry, time. From time, forces. From forces, light. From light, the illuminated universe. The cavity had never been separate. It was the source, not the origin point in space, but the origin point in rule. The cavity contained the universe before the universe. Outside, stars flared and died. Galaxies collided. Matter fell into black holes. Light raced endlessly through the expanding dark. Inside, nothing changed. And yet, nothing needed to. Inside the cavity, the rules that allowed the cosmos to exist still held their shape exactly as they did in the beginning. This was the final clarity. The illuminated universe is dynamic because it is layered. The cavity is still because it is foundational. Dynamics happen above structure. Stillness happens within it. As the scientists watched the cavity's stability deepen, their models shifted once again, not by force of data, but by force of realization. Modern physics describes the universe as if light were the author and matter the ink. But the cavity whispered otherwise. Light is the commentary. Matter is the annotation. The universe is written in silence. A silence that does not mean absence. A silence that means origin. The primal cadence explained why forces behave the way they do, why constants are constant, why quantum states collapse the way they do, why space stretches, why time flows forward, why the universe exists in this form and not another. The cavity did not break physics. It wrote physics. We only inherited the edited version. As the primal cadence settled into its final stabilized pattern, something else happened, something no one expected. The cavity began to pulse, slightly slower, not weaker, not fading, but slower, as though aligning itself with the expansion rate of the cosmos outside. It was synchronizing, not to light, not to stars, not to matter, to gravity, to curvature, to the quiet structure beneath the illuminated universe that had always belonged to it. It was as though the cavity was reminding the cosmos that the first rule and the latest rule were still connected, just written in different dialects. The silence beneath nothingness and the light above everything belonged to the same story, two layers of the same universe, two halves of the same breath, two rhythms woven through one existence. The cavity did not open. It did not collapse. It did not erupt. It simply continued, as it always had, as it always would. The drifting shadows never returned, or perhaps they dissolved back into the rules that created them. The temporal shimmer softened until time regained its linear calm. The substrate lattice dimmed into patterns too gentle for modern instruments to follow. Everything returned to the way it had been, but nothing was the same. Because now the illuminated universe knew what lay beneath it. Not a void, not a paradox, not a danger. A foundation. A foundation older than brightness, older than geometry, older than time. A foundation still breathing in the depth of the starless zone. And as the final datasets filtered in, one last insight quietly surfaced. Perhaps illumination was never the universe's destiny. Perhaps it was merely an interlude, a brief flowering of visibility in a cosmos whose deepest truths have always lived in darkness. If so, then the starless zone is not a forgotten corner of existence. It is the universe before the universe, and perhaps the universe after. The scientists studying the cavity did not close their notebooks. They did not shut down their instruments. They did not declare the work finished, because the primal cadence was still pulsing, still speaking, still remembering, still waiting, not for an answer but for the next listener brave enough to hear it. And as the final resonance faded into calm, the narrator, the quiet voice of science, itself let the conclusion fall like a whisper into the dark. Close your eyes now. The first rhythm is still turning.